Hello everyone and welcome to another episode of the WeAreDevelopers Live Days. My name is Bene, I'm Community Manager here at WeAreDevelopers, and I'm happy that you all joined us today. So today's all about DevOps, but before we start, let me ask you, maybe you were one of the 12,000 people that joined us on our last WeAreDevelopers World Congress back in July. If that's the case, you can go to worldcongress.dev to check out our new photo album there. And also for the newcomers and the people that already joined us, you can claim your early bird tickets for the upcoming Congress next year. And also as a live attendee, you get a small goodie from us, a 10% code for your purchase, for your ticket purchase on worldcongress.dev. And now before we start the day, quick reminder, during the talks, feel free to interact in the chat to your right. If you got some questions, submit them via the Q&A function. But during your interactions, please be nice to each other and respect each other, as we have a code of conduct. Here's a short video about it. And now let's kick off the day with the first speaker. He is software engineer and software architect at Stadtwerke München GmbH. He was developing software for 30 years, and of those 30, 20 of them he spent professionally developing. And he's currently responsible for the IT quality assurance at the Stadtwerke München GmbH. Welcome, Sebastian. Hey, Sebastian, you are muted.
Oh, hi, yes.
Hi. Thank you so much for joining, Sebastian. So, yeah, you're the first talk of the day, and it's actually a 2-hour slot. That's because your talk is interactive, as you told us before. Right. For these interactions to the audience, we will provide you the link and the password in the chat, because Sebastian prepared a board for you. But he will tell you that during his talk. Before we start, Sebastian, could you maybe enlighten us a bit on what we are going to learn from you today?
Yes, we are going to see how we at Stadtwerke München performed a service migration. We switched out our payment service provider for SEPA payments at the beginning of this year. And we did this live. This was a live migration, and we hit several challenges along the way, and we will take a look at them. And I invite you to discuss them with me, provide options, your own opinions, and suggest possible solutions. And I will show you what we actually did and how it turned out.
Sounds awesome. So a great opportunity for the audience to gain also knowledge from your experiences there. So I would say without further ado, Sebastian, the stage is all yours.
Thank you. Well, welcome to my interactive talk, Migrating 500,000 users to a new payment service provider. Here is what you can expect in the next 2 hours. First, we will get to know each other a little bit. Then I will set the scene for the migration. I will introduce mLogin and its payment component to you and describe the circumstances and constraints that shape the migration. As I just said, we will look at a series of challenges we encountered along the way and talk about them, and I will show you how it turned out in the end. I will conclude my talk with a few lessons we can take from this migration and share where we are today and where we are going. Feel free to ask questions in the chat at any time. Bene can interject them into my talk, and I will try to answer them as best I can. This is not meant to be an uninterrupted monologue. There's plenty of time for questions, and I encourage you to come up with interesting ones or boring ones. Any questions are fine, really. So a little bit about me. My name is Sebastian Hans. I have studied computer science at the Technical University of Munich and made my diploma there. Then I worked for Target, a software and consulting company for the financial sector, where I developed products for market data distribution. And I'm currently doing software architecture and development at Stadtwerke München, the municipal utilities company in Munich, which not only provides energy and drinking water, but also public transport and digital services for the city of Munich. I have been developing software since the 90s and professionally for about 20 years. And over time, I have had the opportunity to play a host of different roles, from systems administrator to lead developer, from pre-sales, second level support to integration architect. And most relevant to this talk, I have been lead developer for the mLogin and have in the last 2 years focused on evolving the architecture of the mLogin payment component from within the Agile DevOps team. I carry around with me certain beliefs. One is that software cannot or should not be considered in isolation, but always as part of a social technical system, which means that the people interacting with and affected by the software are as important, if not more so, than the software itself. If this is true about running software, the same applies to the process of software development. The team that develops a piece of code directly determines its shape and qualities, and these qualities need to match the expectations of a variety of stakeholders. So you need to collaborate with them closely, and this includes the people who are going to run and operate the software, thus DevOps. And last but not least, living is changing. Something that never changes is dead. You can either accept this and embrace change or reject it and die. So that's enough about me. What about you? I have prepared a board for this. You can find the link and the password in the chat. Please join me on the board and answer a few questions about yourselves. So this is the board, and I can see already a few of you have joined. When you have found your way to the board, please drag one of the flags here to the map or copy and paste one. You may need to select the arrow tool at the toolbar at the top to select elements and move them around. And for the other questions, you can use the stickies already on the board, drag them around and double click on them to write, or use the stickies in the toolbar at the top to place your own stickies. So I'll switch moderation mode on for a short time to ensure we are all on the same place on the board. I switch it off now so I can zoom around freely. If you get lost on the board, there's a mini-map on the lower left you can use to switch to the leftmost section. Please ignore the others for a moment to not spoil the fun. You can also use the burger menu on the left and click on About You, which will bring you back here. So I see you're already busy placing flags. That's fine. I'll set the timer to 5 minutes and see where we get. Yes, please don't move around the map. I'll just pin it for you. So So we have someone here who is a developer and needs to get good knowledge in DevOps and infrastructure. Okay. My PM forced me. Well, that's kind of the worst reason for being here, but I hope nonetheless you'll get something out of it. To learn about DevOps, to hear interesting info on DevOps. Well, I hope I can provide that. Get informed about DevOps by chance. Well, that's okay. So it'll be a bag of surprises for you. Want to switch career from mobile to DevOps? Well, fine. Procrastinating back thesis? Well, that's as good a reason as any, I suppose. Here's one about getting more familiar with DevOps in the enterprise. Okay. Passionate about DevOps. I'm a student in bachelor's degree of applied informatics. Okay. See what else is there. Always a good reason. So what about the most important aspects when performing major operations in production? There are some answers here already. Cooperation, solution focus, trial and error. I think I can agree with that. Plan, test, monitor. Okay. Automation and backups. Okay, that's two. Test it on dev. Yes, we will see where the limits are during this talk. Trial and error. Teamwork. Inform stakeholders and users. Yes, a very important aspect. Okay, someone's here to find a job. Okay. That might be possible. I'm full stack. I have good knowledge of coding backend and front end, but I lack some skills in DevOps. Okay. We'll see whether this talk can fill the gap. Okay. Someone wrote, don't fear failure. Yes. If you fear failure, it will be certain to get you. Fault resilience. I can agree with that. So about half a minute left. I'd like to have some more important aspects, please. A few more seconds to think about it. Don't drop production. Yes, that's certainly a good one. Okay, someone wrote while here, connect and be more in touch with the community. Yes, we are trying to do that. Okay, so time's up. Thank you for your answers. Now that we know who is here, let's go back to the presentation so we can start to set the scene for our endeavor. But keep the board open, we'll come back to it later. So this is the landing page of mLogin, the company-wide customer login for all our digital services. You can see it yourself at login.münchen.de. And as you can see on the bottom right, an important part of mLogin is the function to enter a means of payment once and use it to pay for any of the connected services. I also have some numbers for you from the beginning of the year. We had about 1.3 million customers, with about 1 million having entered the means of payment. This is because some services are free and require only the login, but no payment. And the means of payment are divided roughly equally between SEPA direct debit and credit cards. As you can see, SEPA direct debit is a very common means of payment in Germany, more so than in other parts of the world. So changing anything there is going to affect a lot of customers. We are processing about 30 to 80,000 transactions per day. The variations are due partly to fluctuation in demand. For example, parking is free on Sundays and does not require payment, and partly to batch payment runs done by some services on some days, but not on others. Many mLogin services are available 24/7, so mLogin itself must also be available 24/7, and this includes payment. So what does the architecture look like? On the left, you see the apps offering paid services active at the time. We have more now, you can see for yourselves on the website, but at the time we had MVG Fahrinfo München, also called Handy Ticket, which sells public transport tickets. We had Handy Parking München, a parking app for public parking spaces in Munich, and MVGo, which is a sharing app that combines multiple mobility service providers in a single app. You can see bikes and e-scooters from several providers on a map and rent them all via the same interface. These services use mLogin for login and the mLogin payment component for payment. And the payment component is a technical integration layer that relies on payment service providers to provide the actual payment functionality. There's one for credit card payments and a different one for SEPA payments. And this is where it's at. We are going to replace our old payment service provider for SEPA with a new payment service provider, Novalnet. Given the availability requirements, this is going to be a live migration. No shutting down the system, migrating and turning it on again for us. It's going to be live. As to the time frame, we knew the contract with our old payment service provider was going to expire on February 21st, 2023. And regulatory requirements meant we would have to hold an EU tender to determine the successor. The tender process was planned to be completed in mid-August, and thus implementation was scheduled to start at the beginning of September. Taking into account the Christmas holidays, this left us about 5 months for the implementation. The team was asked about this beforehand, and we said, sure, this is doable, no problem. As it turned out, however, the tender process took longer than planned, and we were down to 3.5 months. We did have the option to extend the contract with the old PSP, but this would have led to some undesirable consequences I will not go into here, but which were really undesirable. And so we looked at the timeline and said, yes, it's still doable, but we will need to focus. And if any further obstacles crop up, all bets are off. Before I show you how we plan the implementation, I need to tell you about testing payment. Testing payment is difficult. For one thing, the API of typical payment service provider is large. They have to cater to a multitude of use cases, most of which are not yours. So you have to put some work into understanding which parts of it are even relevant. The API documentation does not tell you this. It typically describes what is possible, but not what you need for your use case. For example, there may be multiple endpoints with similar descriptions, or enums with names that may be internally meaningful, but do not tell you when to use which one. It may describe the technical aspects well, but not what exactly happens as a result from a business perspective. Or there may be API functions with dependencies between them that are not obvious from the technical description. This means much of the work is discovery and reverse engineering the API. As an example, see this partial list of error codes on the right. Don't worry, you don't have to read it, but I will tell you that this small extract contains 4 error codes for missing product ID and 2 for double booking. And then there is a successful booking for this session already exists. Can you tell me what the difference is to double booking? Of course you can't. To figure this out, you need to talk to the vendor. Novalnet was actually very good at this, but very responsive, but still sometimes they had to do internal research too before they could answer our questions. And of course, the real truth lies in the system, so you have to test. Send a request and see what comes back. Unfortunately, the test environment is not the same as the production environment, and this is both a boon and a curse. You want tests to accept throwaway email addresses and not fail due to account limits while testing. But this also means that you will not see certain situations during testing and only encounter them in production. Then again, integration is not a one-way process, it is a two-way process. PSPs typically have a myriad of settings for their stores, and the integration process does not just consist of you writing some code and iterating on it until it works, but they have to change things too. There are validation rules, limits, allowed transaction types, and so on. So it is a back and forth between you and the provider. And since changes on the provider side are done mostly manually, you can never be sure whether important settings determined during testing have been correctly applied in production too, until you do something in production. Stores and margins are the counterparts of services on the PSP side. Changes made to one are not necessarily made to the other, so you need to test them all and hope the PSP has configured them consistently in production. Then stability. While the technical API may be stable enough, there are still such things as internal processes and configuration. Last year, we had a lot of fun testing failure scenarios because bank accounts blacklisted for this purpose magically kept becoming unblacklisted. What all this means is that it is practically impossible to test exhaustively before going into production. With these happy thoughts in mind, let us turn to planning. It is now mid-October and we need to decide when to do what. We are going to do this planning both backwards from the deadline and forwards from now. Planning backwards, we decide that finishing just in time is risky. Due to the timing of payment runs for handy parking and handy ticket, we decide to aim for the 17th instead of the 21st. So we have some buffer time left. And given what I told you about testing with payment service providers, we knew that we were bound to miss something and we would have to observe the behavior and make adjustments for some time after going live. Based on this, we decided that a big bang was much too risky and we wanted to stretch the migration over time so we could deal with unexpected issues and iron out any problems before the change was rolled out widely. So how far can we stretch this? This is where legal constraints come in. The payment service provider appears in the general terms and conditions and in the privacy statements of mLogin and all services. So these will need to be adapted prior to go live. Customers need to be notified of the changes 4 weeks in advance, and the service owners told us they could not do it in 2022. So we settle on the 1st of January for the notification. This allows the conditions to become effective on February the 1st, so we can begin the live migration then. This gives us a maximum time window of 17 days from the 1st to the 17th to perform the migration in production. Before this, we need to test our NovaNet adapter and the migration, and we need to let the services test. We do this in a consolidation environment. Planning forwards, we need to get going with the payment service provider API, and this means setting up a test environment, exploring the API manually, and implementing a basic REST client, which can serve as a basis for the NovaNet adapter implementation. This will probably take us until sometime in November. Then we can begin to implement and test the NovaNet adapter and also plan the migration phase and implement any necessary migration code. Now we have planned backwards and forwards, and these backwards plan and this forwards plan need to meet in the middle. What is a realistic time to release something stable enough for our services to test with to the consolidation environment? We decide this time is around the Christmas holidays, probably a bit after. Compared with similar endeavors at Stadtwerke München, the time available for testing in the consolidation environment is very short. 3 weeks, maybe only 2. This does not leave much time for our services to test exhaustively, and the app testers are, let us say, not happy. But given the time constraints, this is the best plan we can come up with. And we know, even if they don't, that the point of diminishing returns when testing with payment service providers comes rather early anyway. So we will just have to live with that. We now know what to do and roughly when we will do what, but how will we do it? To discuss this, we need to know a bit about how the payment process works, specifically payment via SEPA direct debit with sale of receivables, which is what we are going to migrate. We start with a customer. Let's call her Mary. Mary wants to buy a bus ticket. First off, she enters her account number on the mLogin website. The ticketing app will have sent her there, or she may have done this at some time earlier. She only has to do this once and can pay with the payment method thereafter. But this is not the only thing. At the same time, she also grants a SEPA direct debit mandate, which represents the permission to debit her bank account to the payment service provider. This is necessary because we are doing sale of receivables, which means Handy Ticket will not debit Mary's account directly, but will sell the claim to the payment service provider and receive the money from a PSP during settlement, and the PSP is responsible for actually collecting the money from Mary. So the PSP needs permission for that, thus the SEPA mandate. This is important because it means if the PSP changes, Mary will need to grant a new SEPA mandate to the new PSP before her next purchase. Following the call chain, bank account and SEPA mandate are stored by the payment component and forwarded to the PSP, who then validates the bank account and checks out the customer. If all has gone well, Mary can go back to the app and buy her ticket. When she clicks on Buy in the app asks the payment component to authorize the purchase. The payment component talks to the PSP, who in turn checks the credit risk associated with the purchase and sends a positive reply if it agrees to buy the claim resulting from the transaction. Then the app gives Mary the ticket she has just bought and she can ride the bus. All this takes a few seconds. It is much quicker than me talking about it. But at this point, no money has actually been claimed yet. This happens sometime later when HandyTicket starts its nightly payment run. Assuming Mary has only purchased this one ticket, the service will submit a capture request for the amount to the payment component, which in turn passes it on to the PSP. This is when the actual sale of receivables happens. The PSP will then debit the amount from Mary's bank account at some later time and settle with the service, which is out of scope for the payment component. The responsibility of the payment component stops after the capture request has been submitted successfully to the payment service provider. If Mary has bought more than one ticket on the same day, HandyTicket will aggregate the purchases and submit a single capture for the whole amount. Other services do it differently. For example, the bike sharing service aggregates rides over a whole month and captures the aggregated amounts once a month, while fees for e-scooter rides are captured shortly after the e-scooters are returned. There are two wrinkles here that may help us with our migration. First, for historical reasons, the SEPA mandate has not always been required when registering a bank account with mLogin. It was possible to enter an account number without granting a SEPA mandate to anyone. For this reason, there is a check during the authorization step, and the SEPA mandate may be missing. And in this case, the service app will redirect the customer to a special mLogin page where the customer can grant the SEPA mandate and will then be taken back to the app to continue. This will come in handy because at the start of the migration, every customer will be missing a SEPA mandate for NovalNet. So having a way to request it is certainly useful. Second, the payment service provider processing the transactions depends not only on the payment method, SEPA or credit card, but also on the service. This is a configurable routing functionality that has been present in the payment component for a long time, although it was never actually used outside of tests. And so the PSP column always contains the same value for SEPA. For our migration, this means that in principle, the capability to change PSPs on a service-by-service basis at runtime is already there. This is the kind of thought going through our head at the beginning of December, a few weeks into our implementation phase. We had already written some code and were now about to decide how to do the live migration. And this is the first question I want to pose to you. Given what we now know, what migration strategy should we use? Please join me on the board where we can work on that. So here we'll go to the second section. I'll give you a moment to come here. Okay, so once you're here, you can see at the top our timeline. We are now at the beginning of December. The deadline is in February, and it is now December 7th. The question is, what migration strategy should we use? The situation, well, the API basics are understood. We have done the first tests in the integration environment. The time window for the migration is fixed. We are not very in favor of a big bang, but the migration strategy has not yet been decided. I've put some key questions for you there. What do we already have? What is the impact of the migration on our customers? What is the impact on the services? And how do we dose the risk? I have listed 3 options, but do not feel constrained by those. There's a row at the bottom for any other ideas you might have. Option 1 is to use what we already have. We could just switch the PSP per service and be done. The second option, we could do something different. We would have to implement this, but we could also decide to migrate per user instead. Or the third option is we could do a big bang after all. There are arguments in favor of each of those. And I ask you to put your thoughts on the board, on the stickies. You can place your own stickies. You can write questions, thoughts, aspects we need to consider, suggestions. And I will try to answer any questions as they are posted and reply to your stickies. And on the right, you can see a vote column. I see some of you have already used it. Please use the green dots to vote for the option you would go with. And also put your thoughts on the board. I will set the timer to 5 minutes again. And we'll see where we get. I'm looking forward to your thoughts and ideas. Okay, we already have limited time, so go with what is already given. Okay, that's certainly a very strong argument to make. Other ideas? Make sure service doesn't stop. Okay, this doesn't seem to apply only to the migrate per user option. I'm sure you'd want this for any option. Migrate per user. Okay, still much to do. Don't risk it. Big bang is scary. Yes. Play it safe. Put here as an argument in favor of migrating per user. Okay. Migrate per service and test integration between them. Okay. Yes, you can do that. Data are already given, can be used. Yes, it's already there. This is true. In principle, we can just flip the switch and be done. Okay, there's another idea. Try to combine option 1 and 2, group customers and services. Yeah. Just from sticky, I cannot tell how you think you would accomplish this grouping. But it's an interesting idea, certainly. In favor of migrating per service, time pressure, better be fast, yes. Migrate per user, carefully pick the users. Interesting thought. And fine-grained with better monitorability, although more time-consuming to roll out. For the migration per user, yes, that's certainly true. Big bang must be done with all the appropriate testings. Yes. If you are going for the big bang, certainly we will have to test it very intensely. Okay, another idea, migrate per service and user. So combine the risk profiles of both of these options. Okay, migrate per user. Someone says work differently, and therefore you need to make sure it works in all of them. I assume you mean in all payment service providers or in all services? Services work differently. I didn't see that. You can also resize the stickies. Don't have to, just making this bigger so the text fits. Don't feel too constrained by the lines and boxes I put there. Okay, 1 minute left. Do we get some more ideas, some important aspects to consider, questions? Start a service with little numbers of users to test, then go. Interesting idea, yes. Okay. So the votes seem to be pretty divided between option 1 and option 2. Time's up. And only one vote for the Big Bang. Yes, it really is scary and requires appropriate testing. And given what I told you about testing, this doesn't seem too probable. So to see what we actually did, let us switch back to the presentation again, but please keep the board open. And we'll take a look at our considerations and our solution. As to the key questions, we answered them for ourselves as follows. What do we already have? Well, we have a working method to switch the PSP per service. We have a way of dealing with missing SEPA mandates when users try to buy something, and we have good monitoring that lets us observe what is happening in production. What is the impact of the migration on customers? They need to grant a new SEPA mandate. There is no way around this. Due to sale of receivables, the PSPs are the ones who decide on the creditworthiness of the customer. So a customer who has been accepted by the old PSP may be rejected by Novanet and vice versa. So if we were to switch, for example, handy parking to Novanet first, a single customer parking their car and then renting e-scooters would be processed by 2 different PSPs and could be treated differently, causing confusion. They were, after all, paying with the same means of payment via the M-Login. Why would they be rejected in one case and accepted in the other case? Totally intransparent from a customer perspective. It is also not clear which SEPA mandate we should require when entering a new bank account. The old one, the new one, neither, both. There are arguments to be made for and against each choice. What is the impact of the migration on our services? And there is a cost associated with the user registration at the PSP, and we don't want to incur costs for every tourist who has ever bought a subway ticket but will never visit Munich again. Then there is the bike sharing service with its monthly billing cycle. While there is a time gap between payment authorization and capture for every service, for a bike sharing service, this is especially large. Fees for bike rentals authorized in January by the old PSP are going to be captured in the middle of February, right when the migration is expected to be in full swing. Fees for bike rentals authorized in February are going to be captured in mid-March, which is after the contract with the old PSP has expired. Somehow we will have to deal with this. And the last question, how do we dose the risk? Well, we know the rough numbers of users per service. This would determine the step size we would have if we were to rely on the existing routing per service. So switching a small service and to test and then the others might be feasible, but the service number of users per service is not something we can control. And we want to ramp up slowly in the beginning so we can monitor the migration and fix issues as they occur before they become larger problems. So in the end, we decided to ditch our routing per service and to implement routing per user instead. This allowed us to switch over users one by one in the beginning and in batches later, and so ramp up at a rate at which we felt comfortable. And it was really not more than a switch. The real migration and registration of a customer with the new payment service provider would happen when the customer actually tried to authorize a payment after being switched over. This way, we avoided the cost of registering customers we would never see again. And there was one other thing we did. To avoid problems with the monthly billing by the bike sharing service, we decided to migrate each customer renting a bike automatically and have captures by the bike sharing service in February be processed by the old PSP. This auto migration meant we did not have the ramp up entirely under our control after all, But Munich at the beginning of February is cold, so we expected there would not be that many cyclists around and decided to accept this additional organic growth of NovalNet users. Note that auto-migrating the cyclists is not the same as switching the bike sharing service from the old PSP to NovalNet, because if we were to switch the bike sharing service, bike rentals would be processed by NovalNet, but for example, if the user used handy parking later, they would still be processed by the old PSP, whereas with the auto migration, we migrate the user when they rent their bike. And if they park later on, they will then also be switched to NovalNet for handy parking because the user has been switched, not the service. What this means, however, is that we now have non-trivial migration logic, which will need to live somewhere. The existing implementation was biased towards treating PSP selection as configuration and had externalized it in the database. But things like automatically changing the PSP used by a customer no longer fits neatly into a database table. On the other hand, a mapping of users to PSPs fits very well into a database table. So we did two things. We put the main migration logic in the code. This is how we select the PSP for a capture request. In the first line in the if, you can see how we use the old PSP for our bike sharing service for captures in February. MBG Rad is the name of our bike sharing service. And February is before March 1st. So this is the logic. And if it is not a bike sharing capture, we ask the payment service provider source to read the PSP for the user from a database table like this. This is what we came up with. But isn't it risky cementing logic like this in the code? What if we need to change anything? We did not consider this a problem because we work hard to always keep the payment component in a releasable state. This means we don't tolerate a broken main branch, and our tests are good enough to protect us from regressions. Our automated tests, I should add, because almost all our tests are automated. And builds, tests, and deployments are quick. So even if we need to change the code, we can do so quickly and with high confidence. Fast forward to the beginning of the new year, after the Christmas holidays, we are not as far along as we would like. We have been prioritizing customer visible processes over background processes. What this means in practice is we have been prioritizing the registration of new SEPA bank accounts and the authorization of payments and not the capture, which happens later on in the background. We are still going to test migration in mid-January, but we expect to keep developing features that are not on the critical path, like credits, for some time. So this was the situation when our business colleagues came along and said we should inform customers before the migration, which is certainly a good idea. We want to send them an email on the 26th. And we would like to give them a link to grant this NovalNet mandate right away before they run into it when trying to buy a ticket. So this is the second question for you. How can we do this? Please join me on the board again to discuss what to do with this request. So this is the next section. Move one over to the right. The situation is we have major parts implemented, but are still working on items on the critical path. We are still working out details with NovalNet, and now this request comes in from the side. The questions are, what do we already have, and how much time can we spare? I put 3 options on the board for you, but please, any other ideas are welcome. Option 1 is to design and implement the screen flow as we would normally. We would put it into the backlog as an item, have our UX person look over it and suggest a screen flow, and we would then implement it. Of course, we could also refuse the request because we are overloaded as it is. This is effectively the do nothing option because migration will work whether or not users can grant the SEPA mandate upfront or not. Or we could choose to adapt the existing screen with a minimum of effort required to make it work, but not work prettily, maybe. Again, I will give you 5 minutes to put any questions, concerns, and suggestions onto the board so we can discuss them. And please also use the green dots to vote for the option you would go with. Okay, the first suggestion, I would pay attention to customers, and this is put forward as an argument for designing and implementing the screen flow in the usual development flow. Okay, I will note that this is not necessarily very quick and does require coordination with our UX person who is not in the core team. Customer is king, though, so this should be prior. Yes, well, for security reasons, implement the whole screen flow. I'm thinking about what the security reasons might be. Don't know. Better to stay focused on minimizing migration errors. Okay, do nothing. We don't have time, and if we have a similar enough template, reuse it. Yes, there's certainly an argument to adapt what we have. Reduce workload for customer support as an argument for the third option. Well, the first option would reduce the workload the same way. So this is basically an argument against doing nothing. The most votes are for the first option at this point. Other options are not safe enough, not complete. Yes, this is an argument you can make. On the other hand, actually they are. Of course, you don't know the details of how we implemented what is already there, but safety is not the argument that decides anything in this stage. Someone put before doing anything in the other ideas section. So, before doing anything, what? Give users a simple way for reporting any inconsistencies. Okay. So we do have customer support hotline prominently displayed on the mlogin website. So they do have a way to report any inconsistencies or errors they find. Option 3 plus personal support for big customers as another idea. Okay. Well, the mlogin is a login for private persons. So we don't really have big customers in the sense of big corporations we are doing business with who are using mlogin for mission critical things. Okay, any other questions, ideas? Apparently not. Okay, time's up. To see what we actually did, let us switch back to the presentation again and look at the key questions. Well, what do we already have? Well, we had the screen to grant the SEPA mandate, but only for a specific means of payment and with a return to the calling app at the end, so that it could be jumped into from the checkout process and return to the app to continue the checkout after the SEPA mandate has been granted. To make this work with a link from an email where we do not know the ID of the bank account and have no app to jump back to did require work, but not that much. How much time can we spare? Well, the email was scheduled to go out in 2.5 weeks, and we still had much to do, so really not much. But still, giving users the opportunity to proactively grant the SEPA mandate so they would not be forced to do it when trying to buy a train ticket in a hurry seemed a really good idea. So we agreed to squeeze it in, but only put in the minimum amount of effort required to make it work in the first iteration and not to make it especially pretty. So on January 17th, we put a slightly revamped SEPA mandate page online. We added this orange box explaining why a new SEPA mandate was necessary, and after clicking Grant SEPA mandate, the user would be taken to the existing payment page in the mLogin portal. No implementation necessary for this part. The link went into the email on the 26th, and customers started using the link. Later that week, customer service called and said they got calls from people who were confused because they could not see whether their action was successful or not. So on Monday the 30th, we added a green check mark which plopped up after clicking the button and before the redirect to the payment page. This improved life of customer support somewhat, but some users apparently missed the check mark and were still confused. So one day later, we added a green box to the payment page that was displayed permanently and assured customers that everything was fine. Each of these changes was small, quickly done, and could be fitted into our otherwise full schedule. I think we would not have been able to do it otherwise. A full cycle going through screen design and complete testing and implementation in one go would not have been possible without jeopardizing the deadline. A word about contracts. As mentioned earlier, mLogin only provides technical integration of payment processes, but it is not a payment service provider itself. Services do not just enter a contract with mLogin, which includes payment services, but instead services have their own direct contracts with the payment service providers. So if a new service provider is integrated, services are responsible for establishing the necessary contractual relationship themselves before the migration, ideally. It is now January 26th, 6 days before the migration is about to start. The email with the SEPA mandate link has been sent out, so customers are informed that something will be going on starting in February. We have performed the first successful tests in production with a handful of friendly users, which were carefully chosen, as someone has pointed out. But then we get a call from our colleagues from the mobility department, MBG, and they tell us the contracts between our service providers and Novanet are not finalized yet. They are working on it, but some crucial pieces of information are still missing and we might not make it before February. And this is our third puzzle for today. How do we deal with this? Again, please join me on the board to discuss our options. One section to the right, please. Well, the situation looks as follows. The technical integration is 90% done. The critical path has been proven to work in prod, successfully tested with friendly users. Customers already know the migration is going to happen, so there is no postponing it, which is why I haven't even put it onto the board as an option. But the contracts are not yet finalized, so we cannot legally make SEPA payments via Novanet for the services which are still missing the contracts. Key questions are obviously, when will they be ready? What can we do in the meantime? And what is possible to do in 3 work days? Because there's the weekend in between. So working over the weekend would incur overtime. We did not really want to do that, but would if necessary. Options are, well, we can of course do nothing and hope they make it in time. We could choose to offer the affected services only via credit card and not via SEPA. We could fall back to the old payment service provider for the duration for these services and hope they make it before the 21st. We could also offer the service but hold back the captures and submit them or block when the contracts are ready. Or we could do something entirely different, and I'll be glad for suggestions. Please put any questions, concerns, and suggestions or alternatives on stickies and vote for your favorite option with the green dots. I will set the timer to 5 minutes. And have a go. Doing nothing. Everyone has its own responsibility. It has done the best. Okay. That's a stance you can take, which will make the mobility department decidedly unhappy. Fall back, not much is possible in 3 workdays. An if statement should do. Okay. Question, does this require additional work from your side, falling back to the old PSP? Yes, it does, but not too much actually. So the sticky on the left is not too far from the truth. There's 1 vote for doing nothing, many votes for falling back, and no votes for any of the other options. Falling back, this seems to be the easiest option to be done on time. Changes can be made later. Okay. Someone votes to offer the service but hold back captures. This would have been, I think it would not have been really much more work than falling back to the old PSP. What about our expiring contract? Yes, well, that's the big question. It will still expire on February 21st. We could possibly prolong it, but MVG was strongly opposed to this. So it would have had various negative consequences we were not willing to bear. So we are looking for other solutions before going this route. Fall back to the old PSP. Old SEPA is already ready. Ask a new SEPA later. I assume you mean the SEPA mandate. Yes, that is correct in most cases. There may be some users who have not granted a SEPA mandate for the old PSP or the new one, who would have to grant a SEPA mandate for the old one for this fallback solution. Offer service but hold back captures. There's someone who wrote compare costs of legal issue versus additional costs for development. Yes, Stadtwerke München are very risk averse when it comes to legal issues. And as soon as you put the legal people into the loop, things get dragged on, I can tell you from experience. So this is not a quick solution in any case. Yes, the fallback is possible and it is a short-lived solution, but it's only a solution until February the 21st. Then everything would stop. Yes, that's true. Okay, 1 minute left. I think the options listed so far indicate strongly that there will not be other ideas forthcoming. So I think I'll stop this one early or put a sticky on now. Okay, so let's see what we actually did. I'll switch back to the presentation again. And briefly recap the key questions. When will they be ready? Well, we don't know. But they are working really hard on it, and they are really motivated to get it working before February the 21st. So we kind of banked on it not taking weeks, but rather days. What can we do in the meantime? Yes, the options have already been listed on the board. Doing nothing is, of course, the simplest option, but risky. We could offer the service only via credit card. It would be easier than falling back to the old PSP or the other option, but because it would be configurable on our side, but it would lose us business with customers who were unable or unwilling to enter a credit card instead of their SEPA, which did not work for these rentals. We could fall back to the old PSP. This would be a rather small implementation issue on our side, or we could hold back the captures until contracts are finalized and submit them then. This would have been in my opinion, also not that big implementation issue on the server side. So it comes down to what can we actually do? And we said, yes, we can implement something if it's such a simple piece of logic on our side in time. The service team said, no, they did not feel they could do this in time. So we chose option 3. Our migration logic resides in the code. So this is what it looked like. We added a clause that would choose the old PSP if configured for the service. We made the service list configurable in this case because we wanted to be able to change it on the fly should the situation develop further. We deployed this change to production on Monday the 30th. Later on the same day, we got a call. Ta-da! Well, who would have thought it? So we removed the clause again with a deployment on the next day. And by the way, the removal was not a rollback to the previous version, but a normal release that contained other changes, namely last-minute adjustments required to match an altered job structure at the PSP. This was the last surprise before we went live. So now it is the 1st of February. On midnight, auto migration for the bike sharing service has started, and apparently some people have already tried it during the night, because when we came into the office early in the morning, we found payment authorization errors in the logs. Even though we had tested everything, and even though we had tested with friendly users in production. In hindsight, it must have had something to do with the last-minute change to the shop structure I just mentioned. Some configuration got lost because it was a manual operation on the service provider side, on the payment service provider side. Did I mention testing with payment providers is difficult? Anyway, we called Novalet and they configured something and authorization started working again. By midday, we had 171 successful payment authorizations via Novalet and 20 captures. These were for e-scooters. The first captures for the ticket and parking services came in during the following night. Over the next few days of slow organic growth, triggered only by these auto-migrated cyclists, we observed a few corner cases and fixed them. For example, in certain situations, captures could fail and we added a check. Whenever we received a capture for a user who did not yet have an authorization by Novalet, we would fall back to the old PSP. And then it was time to turn the throttle up. Up to now, all customers had still been using the old PSP by default, including new ones. On Monday, February 6th, we changed this. We pinned all existing customers to the old PSP in our database table and changed the default SEPA PSP to Novalet, so new customers would no longer be registered with the old PSP, but with Novalet. After this, we began to migrate pinned customers in batches, starting on the 7th with 1,000 most active users, and increased the batch size daily. All the while, we observed what happened in production and made a few minor adjustments. On the 13th, we had migrated 70,000 customers in total and had about 8,000 captures for the weekend processed by Novalet, which is about a fifth of the usual amount. However, we noticed one thing. Some of the payment authorizations had timeouts during requests to the payment service provider. Because the authorization step happens synchronously during checkout in the apps, this meant that checkout failed and customers had to retry. What do we do now? This is the fourth scenario I would like to discuss with you. Please join me on the board and take a step to the right. The situation is as follows. We had 70,000 customers migrated. There was another batch of 100,000 customers planned to be migrated today, but we had these authorization timeouts. Questions we ask ourselves at this point are, what do we do about the migration? What can we do immediately as opposed to finding a long-term solution? And what is the impact on customers? I have a few more options this time. I have to zoom out a bit to fit them on the screen. So here we are. Well, we can, of course, do nothing, which means we proceed as planned with our migration schedule and keep observing what happens. We could just increase the timeouts. After all, if requests are timing out, maybe they would succeed if we increase the timeout and then proceed as planned. We could choose to skip today's migration batch in order not to make the problem worse and keep observing. We could skip the batch and call Novanet and talk it over with them. And we could also choose to authorize payments despite the timeouts and accept that captures may fail, thus keeping customers happy but taking some risk. So these options are not mutually exclusive, so you can be in favor of multiple options. So please think about what your immediate reaction would be, not finding a long-term solution, but what do you do right now? And put your thoughts on the board, suggest alternatives, and vote for one of the options. Again, I will set the timer to 5 minutes. And I'll turn off moderation mode so you can zoom around on your own. There are some votes already for increasing timeouts, skipping today's migration batch, calling Novanet. So again, the effects of this error are customers who have been migrated may run into timeouts. Not all of them do, but they are occurring sporadically. And if they do, they will get an error displayed in one of the service apps and have to retry the purchase, which will probably work. So increasing timeouts and proceed. This plus 4, since we don't want to make our problem worse. 4 is calling Novanet and skipping today's migration batch. Okay. Increasing timeouts, give further chance, give a new email to authorize or stop the service. Payment authorization does not have anything to do with email. It is the step where the payment service provider checks whether the customer is creditworthy and decides whether to accept the sale of receivables, whether they will buy the claim resulting from the purchase. Skipping today's migration batch and calling Novanet, play it safe, better safe than sorry. Okay. Authorizing despite the timeouts. I'll be very pissed off if your technical problems are messing with my day. This is written from a customer perspective, I assume. Yes, well, customers who are getting errors will probably be pissed off, yes. Other ideas, increase timeout and proceed as normally in call Novanet. which would mean migrating an additional 100,000 customers today. Yes, we could do that. So the last option, banks could sue you if you make a mistake. I don't really agree, because captures failing do not mean that the bank has any kind of problem. It just means that the service will not be able to submit the capture to the payment service provider. This doesn't have anything to do with the bank yet. Because the payment service provider will only try to debit accounts for which it has agreed to accept the capture. Okay, skip today's migration batch and call Novalet as one sticky that says if they have responsibility, they should help to solve the problem. Yes. Can't say anything against that. Okay, so the majority of votes goes to calling Novalet and skipping today's migration batch. There are some votes to increase the timeouts and some to skip and keep observing. I assume this means keep observing without calling Novalet, because otherwise it would be option 4. Okay, thank you for your thoughts. Time's up, and I will show you what we actually did. So back to the presentation. What were the key questions again? Well, what about the migration? We had a plan to follow, but there was wiggle room. We had planned the last batch for the 15th instead of the 17th, which we were aiming for, but the 17th wasn't the deadline. The 21st was the deadline, so we had some room. And the delay for one day would not hurt us too much. What can we do immediately? Well, some thoughts on the options. If calls are slow, why not simply increase the timeouts? Yes, well, however, our apps have timeouts for authorization requests to the payment component too. We had already discussed the topic of timeouts with the app teams in the past, and they were strongly in favor of short timeouts because customers do not wait around silently if there doesn't seem to be progress displayed by the apps. They will tend to click around, abort the transaction, do something else. So increasing the timeouts would probably not have the desired effect. Since it was calls to Novalet that timed out, it certainly made sense to call Novalet and discuss the issue with them. We could also have decided to just let users buy if replies took too long and accept the risk the captures would be rejected later on. But since the payment component is only a technical integration layer, we could not decide to absorb the losses on our own. We would have had to talk to the services about this. And of course, doing nothing is always an option, but in this case, we would have run the risk of payment errors on a wider scale, and we certainly did not want that. What is the impact on customers? Well, they would experience flaky checkouts in the apps. Increasing the timeouts, if we could negotiate it with the app teams, would have meant longer wait times, and customers would probably abort the process and retry anyway or leave. So we first decided to skip today's migration batch and then called Novalet. We were collaborating closely with them after all. They were monitoring things on their side. We were monitoring things on our side, and we were constantly in contact anyway. They were very responsive and really wanted the migration to succeed and not appear unreliable in the eyes of the customers. So they agreed to buy claims for purchases for which the authorization had timed out. In doing so, they took on the risk of default, even cases where they would have normally rejected a customer for the migration phase. This allowed the payment component not to fail in case of a timeout, but issue a positive authorization to the service so the checkout could proceed after some time. We changed the code accordingly and put it into production on the next day. Then we resumed migrating customers in batches as planned and observed the effects on our monitoring dashboard. It worked. We had eliminated the main cause of errors by cooperating with our payment partner and finding a solution for now, which is only half technical and half based on an informal agreement. Later, of course, there were additional changes to fix causes, and so we have a stable solution now. And that was it. There were minor issues to work out, but no major problems. And on Thursday, February 16th, 5 days before the deadline, all customers were migrated. We were done. But were we really? What about the scaffolding we built and the debris left over after the dust had settled? What about the adapter for the old PSP? Leaving unused code lying around is generally a bad idea, so this has to go, obviously. We removed it from the code base. What about the fallback logic we implemented to deal with certain migration scenarios? This is useless without a PSP to fall back to, so it has to go too. The first time users try to buy something after being migrated, they have to be registered with Novanet. What about this on-the-fly registration? Actually, we are going to need this indefinitely because in a year's time, there may still be users who have not interacted with payment components since January, and they will need to be migrated too. So it stays. What about the orange box on our SEPA mandate page? Well, maybe at some point we will drop it, but for now it stays too for the same reason. And the green box on payment page, this is the only indication whether a customer has granted the required SEPA mandates, so we are going to keep it for the foreseeable future. And what about the PSP switch per user? We deliberated a bit about this one because it might still be useful, if only for testing purposes, but in the end, we decided to remove it. There is no further migration on the horizon, and if one comes our way, we will build exactly what we need then, just as we did this time. Until then, simpler is better. We are not going to bring back PSP routing per service either. If we have to do something in similar, we will do it in code. So that's it. Now we are really done with the migration, and we can look at some lessons to draw from it. First, success depends on more than coding. To pull this migration off and to keep payment with mLogin working, we need the working software, sure, but we also need close collaboration with Novanet and continuous communication with other stakeholders like our services and customer support, whom we kept up to date with our schedule and daily progress reports. The contracts need to be in place. To be able to react to unexpected challenges and unforeseen developments, we need a well-oiled build and deployment pipeline and a motivated team to work it. We need good monitoring by the team. And last but not least, payment isn't worth anything without customers willing to pay, so we always have to keep those in mind. Payment with mLogin is a social technical system, and if you recognize it as such and treat it as such, you can do things you could not do otherwise. For example, perform a payment service provider migration with user interaction in 3.5 months. The second lesson, or maybe a corollary to the first, is that you need to understand not only your own system, but also the context it is operating in. To make our migration a success, we needed to know about the different behavior of the services, their billing cycles, and their checkout flows to ensure they continue to work as expected during the whole of the migration. Part of the inner workings of our payment service providers and of their differences, for example, how they treat captures in relation to prior authorizations, how payment providers work, because this helped us decide on the best migration strategy. Legal dependencies, like changes to the general terms and conditions, which constrained the time frame we had available for the migration. Had we not taken this into account, we might well have been blocked by them shortly before the planned go live and been forced to extend the contract with the old PSP after all. The business impact of the processes we were implementing. For example, SEPA Direct Debit and SEPA Direct Debit with sale of receivables may look technically identical, but when you get to topics such as SEPA mandates and risk trade-offs, it makes a world of difference. So if you want your software to succeed, it is not enough to understand the code. You need to understand the context it is operating in. Then, fast feedback from production is crucial. There were so many situations where we reacted to what was happening in production, where we changed our code, worked with NovalNet, or adapted our migration schedule because we were seeing what was happening in production. When users were confused whether granting the SEPA mandate had worked, we quickly added visual feedback. When we saw authorization errors just after beginning the migration, we talked to NovalNet and got them resolved. When there were capture errors, even if there were only a few in the beginning, we were able to come up with solutions and deploy them quickly. When we got authorization timeouts, we were able to assess their importance, pause the migration schedule, and get the issue resolved before they had caused greater problems. We could do this because the development team is also the team that deploys and monitors the software in production. This, for me, is what DevOps is all about. And one other thing, if you are trying to do something complex, take small steps, observe the results, and adapt to the circumstances. Performing complex operations is like navigating in the jungle. There is limited visibility. Unexpected things can lurk around the corner. You can have hypotheses on what the best way might be, but they may turn out to be wrong. So moving in leaps and bounds is very dangerous, and you really should take small steps, look around, and by all means, follow your plan, but be prepared to react and maybe adapt your approach when a leopard appears. Being agile helps. DevOps helps. So here are the lessons on one slide. If you remember nothing else from this talk, remember these. Success depends on more than coding. You need to understand the context your system is operating in. You need fast feedback from production and do complex things in small steps, observe what happens, and adapt what you do. So where does this leave us? Today, the mLogin user base has grown by about 50%. From time to time, we find a new error code or situation in our logs and figure out how to deal with it. This is business as usual when dealing with payment. We are currently in the process of moving from our private cloud to the public cloud. We are using Terraform to manage our infrastructure as code, although to me it operationally feels less like code and more like managing a database schema. This move also brings with it changes in the areas of responsibility for teams. We're still discussing how product teams, platform teams, and operations are going to best work together in this world. And in this context, we will need more people who are interested in DevOps, working in product teams with end-to-end responsibility or supporting DevOps teams. If you have any questions about this or about my talk or about Stadtwerke München, now's the time.
Sebastian, hello again. Thank you so much for your talk. It was very informative, and I also loved like your last one with lessons learned from today. I think that helps lots of people to recapitulate all of this. So thanks for that. And as you already mentioned, now is the time for questions. But since we also got some questions about recruiting at your company, we invited two of your colleagues, Carla and Elisabeth. I would say they can join also now on stage. Hello, Elisabeth. And hello, Carla.
Hello.
Wonderful
Hello,
to have
everybody.
you also.
Hi.
Would you two mind to maybe
together.
introduce yourself really quick to the audience?
Okay, I can begin. I'm Elizabeth. Hello to everybody. I'm working at the Stadtwerke in Munich more than 20 years, always in the HR department. I began in another department and switched to the recruiting department, I think 8 years ago. And I'm focused on positions which are related with IT in several companies of our great company. So, and I'm always looking for IT developers, and very happy to hear your questions.
So my name is Carla Fernandes. I'm a colleague from Elisabeth, not so long as her in the company. I'm only 6 months today. And I support Elisabeth on her team for the IT, also for the engineering. Yeah, so this is all about me.
Right, thanks for that. And since you're freshly joined and Sebastian maybe needs to rest his voice a bit after this over 1 hour talk, let's start with some recruiting questions to the both of you. Let's start with, can you tell me more about the company culture and values you have at the Stadtwerke München GmbH.
Of course we can. I think the most interesting thing is that we have strong values, and we are based on the people who are working with us. That's what we get from feedback from other people who join our company. If they are here, they say, okay, this is a company which looks on the people. So we have a lot of benefits for the people, and we would like to give the all possibilities to people. Maybe Carla, you could tell it a little bit more, because you know maybe a little bit better than me.
Yes. Stadtwerke is an employee-oriented company, so we can live this every day here. It's a flat hierarchy. We have everybody has the same freedom to speech here. You are valued, you are respected, all from all kinds. It's a company where you feel very welcome. Everybody, even for the another teams and sections, it's like the same team. This is very nice to see, and I live this since the first day.
Thanks to the both of you. Then let's go on with another recruiting question. Can you describe the typical career path or a typical career path for someone starting at Stadtwerke München? And maybe do you even have a success story to share?
I think this one I could start, because since I'm new, I would say in the first 3 months, you started a lot with your notion of what your tasks are. Everybody has a very well-oriented plan for you in the first day you started. We as recruiters, we helping the candidate with the whole candidate experience, and we introduce to the team. So the team, since the first day, this employee, they have to take care of the employee experience since the first day one. So they also have, everybody has a very structured plan with your daily work, and everybody has a chance to meet his tasks and to learn his tasks, and this is well done. And right now, as I said, I finished my 6 month, my probationary period, and now I have to choose a little bit more focus and where I'm going to do as recruiter, for example, as my experience. And I just started to recruiting now for the engineers, for example. And after the next year, since I will be 1 year, I will be in another team as well. So we have a career path very structured since the day one. And this is, you always can agree and arrange with your supervisor and your team.
Maybe I can add it a little bit concerning the IT department. For example, if you start from the university, maybe from bachelor or master, I don't know. So you can start, for example, as a developer, and then you get your experience for many years, and there's a possibility to get maybe an architect, maybe a software architect, maybe an enterprise architect, or you can go to get a hiring manager. We have several career paths, so you can go into then the space of experience, or you can go to the hiring manager, or you can go to the project manager. And these career paths are equally, and you can switch from one to the other one. There are a lot of possibilities.
Happy to hear that. Thank you so much for the answer, the both of you. The next question is to maybe all three of you, since Sebastian, maybe you also have 1 or 2 sentences to share about this. What's the company's mission, and how does the tech team contribute to it?
I can start with a mission. Our mission is, you can trust on us. Man kann uns vertrauen. That's our mission. You will find it everywhere. You will find it everywhere in the city. And that's the thing, you can trust on us in the city with the water, with electricity, with the mobility, and with every part of the public thing. We call it customer value, citizen value. And that's the thing we are working for.
Do you also have something to add regarding the tech team, in particular, Sebastian?
Well, the tech team, generally, Stadtwerke München is keeping the lights on in Munich. We provide energy, we provide water, we provide several digital services like parking service, apps where you can buy public transport tickets, and our mobility department operates the bus, the subway, and the tram in Munich. So all of these are supported by IT. We have a lot of IT going on at the Stadtwerke München, and we support it by introducing software solutions which support, for example, the management of our subways, bus fleet management. The part where I work, we provide digital services, the login for the apps. We build the apps ourselves. The services I mentioned, Fahrinfo München, Handy Parken, and the MVGo are all developed in-house. So there's a lot for IT to do.
I can imagine. So without Stadtwerke München and in particular the IT department, life in Munich would stand still. I can assume. So maybe let's stay with you for a second, Sebastian, because we got some technical questions. The first one, if you decide to migrate per user, how do you choose a test user? How do you choose which customer to be migrated first?
Good question. We, of course, migrated ourselves first. We are the ideal test user, each one of the development team and our product owners, and pretty much everyone working in the department has an M login. So obviously we migrated our own accounts first. We did this before February 1st because even though the general terms and conditions were not effective at the 26th of January, we agreed to migrate our accounts ourselves and use them to use various services and pay for them. And these were the friendly users I mentioned. The next batch chose themselves because we decided to auto-migrate all users of the bike sharing service. So whoever rented a bike was migrated. This was not something we were entirely happy with because we had no control over it, but we needed to do this due to the monthly billing cycle. We needed to keep all authorized payments from January, which were authorized by the old PSP, separated from those authorized during February, which were going to be captured by the new PSP. After this, we decided to use the 1,000 most active users. We queried those from the database, and we hoped that they would remain active and provide us with particular insight during this early phase of the migration. And after this, we just took batches of random user IDs from our database table and migrated them.
Right, thanks for that. Yeah, the steps make totally sense, I think. And we got another tech question for you. Changes of the SEPA PSP are probably an issue multiple companies face. This talk can now help other companies. Did you take steps to collect experience from other companies prior to the migration?
Actually, we did not, because in interacting with the payment service providers is not something companies talk about very often. So maybe this talk will help others. I hope so.
Exactly. All right. Thanks for that. One more tech question. Is the customer experience also improved during the migration, or was it just beneficial for Stadtwerke?
Well, it started out as a migration that was necessitated by the contract with the old payment service provider running out, and it needed to be replaced by a new payment service provider for, well, we need a payment service provider for SEPA, so we need to choose a new one. That it wasn't the old one was the result of the EU tender. So the intention was not primarily to make life for customers easier. It was just that we were required to choose a new SEPA payment provider. There were some small parts that may help customers. Before the migration, we did not have any indication as to whether there was a SEPA mandate granted or not. We now have this. It's the green box on the payment page. It will stay there for this reason. But the main objective of paying via SEPA is to remain as invisible as possible. As a customer, you do not really want to interact with payment. It's something you do because you want to do something else. So we try to stay out of the way as far as possible.
Totally makes sense. Thanks for that answer as well. Now, since we talked a bit about recruiting and the mission beforehand, now the big questions, do you have open positions in IT and how to apply?
Of course, we have open positions. For example, positions for software developer. I think Carla can add there a little bit, and we have a system for this.
Yes, right now it's under my control some developers positions, and I would say we have per month like 1 new open position this area, and you can apply if you go to our career page svm.com, and you can find there many as you want.
All right, sounds promising. Maybe also as an additional info, since the question came up from the audience, to the both of you, do you recruit for remote roles? And if not, have you done relocation in the past?
There's one position we are recruiting for a remote role. It's in software architect SAP. The other positions, for the other positions, we have a so-called hybrid model. So we would like people to be in the office maybe 2 days a week. So you can work from home 3 days, but we like people to be in the office 2 days a week because we think it's good to meet other persons, to have personal contact to others. That's important for our company.
In particular, in the beginning, it's very important to learn your colleagues. Exactly. And another recruiting question, that's maybe more general, so maybe we can define it down to one role. The question came up, what does a typical day look like for someone working at your place? So maybe this is more also a bit to Sebastian. Maybe you can share a bit about your work day there.
Yes, I assume it's about a typical work day for an IT person. So this depends on which team you are in. I can speak from my experience. I'm part of a DevOps team concerned with the mlog and payment component. So my typical day consists of some parts of coding, architectural decisions, and discussions. We have a daily. We are not using Scrum, but other teams are. We still have a daily. We have a weekly meeting for an hour where we discuss what is coming up and any issues, discuss new backlog items and so on. And for me personally, I'm doing work outside of the team too. I'm responsible for quality assurance for the IT department. and there are some things that are going on that are not part of the product team work, but you probably won't have this if you just join freshly.
Of course, maybe also for the people that are considering to join, can you also provide more details about the technologies and tools you use at Stadtwerke in the IT department?
Yes, I can tell you what we use for mlogin and most parts. We are a Java company. The parts that are not SAP are in Java, and we at the payment component team we are actually using Kotlin running on the JVM. The application is based on Spring Boot and uses a PostgreSQL database in the backend. The front end is a TypeScript Angular, and we use Redis and RabbitMQ for various purposes.
Right.
So
Thanks for sharing.
at the moment, we are on an internal cloud platform, but we are moving away from this, and the target is to be on Microsoft Azure by the end of the year.
All right. Thanks for sharing this as well, Sebastian.
And I
also,
have something to add.
Yes.
To Brevis' question, it just bounced around my head for a bit because someone asked whether we had been collecting experiences from other companies before taking on this migration. And well, we did not go around asking other companies how they did this, but of course, the people on the team had partly already done this at other companies. So it is not as if we were running around with no idea what we were getting into. So if this counts as collecting experiences, yes, we collected people who could do this.
Well, of course, yeah, the experience of each teammate is crucial for operations like this, of course. Yeah, thanks for also clarifying this. And maybe another question for people that are interested in joining: how is performance measured and evaluated within the tech team?
Shall I? We have not.
Yeah.
Maybe it's best to tell you how it's not measured. We do not measure lines of code. We do not have individual metrics which are pulled from thin air, which you have to fulfill. It's a conversation in the team, and we have a quarterly talk with our line manager, who is not actually involved in the product development at all. He's just a line manager, and he gets feedback from other people on the team on how they view your work, and it gets feedback from you how you view the work of others and how well it works when put together. So there are no individual targets you have to fulfill, which will always be artificial. We had already tried this in the past, but we have given up on it because it doesn't work.
Yeah, for the better. All right, thanks for that. Another question to all of you: what opportunities for professional development and training are available for employees at your company?
I can begin to answer this question. I think professional development and trainings are very important for us. So we give I can say each possible possibility to people who want to develop and who want to develop technical or personal skills, and I think we say in the average per year there are 7 days for professional trainings or for professional development. In the average, maybe there are people who have 10 days the year or have only 3 days, but the average is 7 days a year. Maybe Sebastian, you can agree to this because you have the experience in the IT department.
Yes, it is used to, so you are not looked at askance if you actually use your learning budget. So it's encouraged, and I would think it very strange if a new candidate wasn't interested in learning.
We
Of
also
course.
have an intern catalog for e-learning, which they offer for free. For example, many tasks to develop, as much as in the technical area as in the soft skills area as well. Just to add that.
That's awesome. Yeah, that's a very good point. Thank you so much for adding that, Carla. And to you, Sebastian, we got some more tech questions. People were very intrigued in your migration process because also the question came up, why adapter for old PSP be removed? Can it be archived instead?
That's what version control is for, I would say. We delete it from code. Of course, we use version control. I don't think in this day and age there are still people not using it, so it will not be gone forever. If we ever need to integrate with this payment service provider again, we could pull out the code, but I think it is extremely unlikely that their API will not have evolved in the meantime. So it probably would not be of any use.
Okay,
but we can get back to the old version, of course, yes.
All right. Thanks for clarifying that. And next question. During this migration process, were there customers complaining about the migration, or were they bothered in any other way?
Well, there were some instances where customer support was called because customers did not understand certain things. For example, they were confused by the SEPA mandate granting page because of the lack of visual feedback. There were certainly some customers affected in this way. We did not receive any signals from customer service that customers were yelling at them or something like that. I think I also did not get feedback from the app teams that reviews in the app stores have dropped to abysmal levels or something like this.
And no feedback is often the best feedback you can get because
as well there was some feedback from customer service, but of course it is the function of customer service to handle the easy issues themselves. So
of course
there was nothing critical really that got back to us except for this confusion because of lack of visual feedback.
Right. Thanks for this answer as well. Then also during this whole process, what were your key learnings from all this migration? And maybe also as a next question, what would you change next time when you're doing such a huge process?
Well, the key learnings are what I already shared with you. Before, you need to know the context your system is operating in. We would not have been able to do this migration without an understanding of how our services were using the payment component, of what SEPA mandates mean legally and how important they are in the process. And moving in small steps and gathering feedback and reacting to it is still crucial. These are the main points. And testing with payment service providers is hard. So you cannot, while you may feel that you need to test everything to exhaustion before taking on such a project, it simply will not work. We did test payment with the bike sharing service, and then something changed out of our control, and it did not work when we started in midnight. So you have to be in close contact with all parties involved, which meant we could call NovalNet at any time, and they were very reactive. And this is what made it work, basically. Not testing upfront. We would have wished for more time upfront. We planned with 5 months, but got 3.5. But testing more would not have prevented this particular issue. I'm very sure of this. So there will still be issues cropping up, and you need to be able to react to them. What I would change, well, I would give us more time actually, because it was, well, I wouldn't say stressful, but it was an intense time. We did actually all get our Christmas holidays. Nobody had to work over the holidays, over the weekends, during the nights. But a little bit more time would have been good. As to the decisions we made, and which I outlined in my presentation, I don't think we would change any of them. Maybe the bit about visual feedback, with a bit more thinking time, we could have included this right at the beginning, but we were able to deliver it later on, so not much harm done.
But yeah, very good learnings for next projects. And before we go on to the next project, we also got some more recruiting questions for Elisabeth and Carla. So maybe a more general question again, is there anything specific you're looking for in a candidate applying for jobs at your company? Are there some key factors you always take in consideration?
I think, of course, we are looking for technical expertise, and we are also looking if the candidate fits to our company. So that's the social skills, I can say. Carla, what would you add?
Yes, each vacancy depends what is searching specifically, but mainly we expect, of course, some experience, and sometimes we do need that the person has some degree on this position, but sometimes X years of experience is also applied, but really, and sometimes we need also someone with soft skills, as we had in our interview questions specifically for that. Yes, and some level of German knowledge is also required too at our company. The person not necessarily needs to be native or a speaker, but at least B1 is necessary for the jobs at Stadtwerke. Even if you have not so much knowledge in this in a language, we offer German courses as well for everybody. So this is something very important to mention.
So yeah, really everybody can apply, and you're supporting them with learning German. Okay, that's really awesome. Because German, I mean, I'm a native, but I can imagine it's not the easiest language to learn.
I can agree with you.
Yes, but we earlier talked a bit in German, and it was really, in German we would say Lupenrein. All right, thank you.
I can add to this a bit from a technical
Sebastian.
perspective.
Yes.
We are not looking for a perfect technological fit in the candidates. You don't have to know Spring Boot by heart, or need to be able to code an Angular app with your eyes closed. But we expect you to be able to learn, to be interested in learning, and to put in the energy and do it. You'll get time for it, as discussed earlier, but we expect you to be motivated and to groove yourself in.
All right. Yeah, thanks for adding that also. Since Carla and Elisabeth, you mentioned that there are certain soft skills you're looking for. Can you maybe specify a bit or give some examples on what these soft skills are exactly, what you're looking for in a candidate?
Okay, for example, I can tell you the ability to work together, to work in a team, to cope with different meanings. I think that's one thing which is very important in our company. You can say what you want to say, but you have to cope with the different meanings and to communicate with other people.
Yes,
Carla, what
and
would you add?
yeah, sure. I would add that our questions are based on biography questions or self-related experience questions. And as Sebastian just said, you don't need to be the master experience in that position, for example, but you need to show us that you are able to learn, that you are willing to learn, that you are motivated to learn, that you can organize yourself to learn, and also your ability to elaborate a conversation, the ability, because in Stadtwerke we offer, as Elizabeth said already, this hybrid offer, which you can work from home and go to the office as well. So we need someone who are willing to go to the office, who see the being together with colleagues important, because this is the person what we are looking for. Someone who is willing to develop himself as a professional, but also as person.
Yes, this means we are not looking for the prototypical hacker performing wonders in his cellar alone with the closed and the lights out. We are looking for people who can communicate with their teammates, share their status, talk to them, talk to other stakeholders like the business people and service providers. And
yeah, I also saw these movies with the hackers in the cellar. Kind of related to the soft skills and all this communication and team spirit part, another question would be, how does the team handle conflict resolution and challenges that arise during projects?
That's for Sebastian, or?
we talk to each other. Okay. So, it sounds trivial, but talking really helps. If you are willing to listen to the other person, this ties in with the soft skills we expect. So yeah, there's of course we have escalation levels and all that, but we hope we don't need them. So typically the conflicts which arise typically are resolved by the parties involved.
Right. Yeah. Thank you. Then let's go on to the next question. Let's circle back a bit. Carla, earlier you talked a bit about the beginnings at the company as a person. So maybe you are more in touch with this. What is the onboarding process like for new employees in the tech department? Or maybe more to Sebastian.
Yes.
Who should
Read
answer
questions
this
because
question?
I can
the connections.
I can say something about this. Well, we onboarded a few people. You are typically part of a team. When you get to Stadtwerke München, we are hiring you for a reason, so you will be assigned a team, and your colleagues will onboard you, show you the ropes, what their tech stack is, show you your work environment, help you get set up with an IDE and everything you need for development. And there is also a more general part to onboarding, which my recruiting colleagues can tell you about. But
Okay,
the
general
technical onboarding will be done by the team.
Yeah, the general part of the onboarding starts at the point when you sign the contract and send the contract back. And then there's the beginning of the onboarding process, which means that you get a lot of information till the first day. So you have, for example, a virtual walkthrough through our buildings, or you get a lot of information about our benefits and so on. And it's everything until the first day when you come here, when you get your laptop and your equipment and everything, and then you start your technical onboarding. That's a very long process.
I can imagine. Yeah.
Just to add, before that, this onboarding process, the candidate process, we need when a person applies themselves, as I said already, in our page, for example, as LinkedIn or any other job pages like that, it's good if the person sends not only her the CV, but also some documents who, for example, about work recommendations or the degree of the or certifications. It's always good to have more documents to speed up the process, because if the person doesn't give that or informations as the start date or salary expectations, so if the person doesn't give this information, we need to delay the process, because we still need to ask for those informations to send to the team to prove if this person should go to an interview or not. This is important to add.
Right. Yeah. Thanks for clarifying also that. And maybe as a closing question to Sebastian, since you showed us all this process today, what are your plans for the future? And are there any other huge migrations on the horizon?
Not yet. So the contracts with our existing payment service providers will run for a few years. Maybe we will have a migration then, but maybe not. Maybe we'll choose the same one next time as we did the last time. So we don't know yet. As I said earlier, we are currently on our way to the Azure platform. So this is a technical migration of which the users should notice nothing in the best case. And when we are there, we probably won't move away immediately. So we don't have any large migrations planned for the foreseeable future, but there are many small tasks and issues to tackle. We have a few more payment processes we want to integrate and improve several key points in the user experience.
All right. Then your next employees already know what they're going to work on with you, Sebastian. And thank you so much for the talk. Also to you, all three of you, thank you so much for the very informative Q&A. I think we'll all learned a lot from you today, and hopefully until the next time.
Well,
Thank you
thanks
very
for
much.
having me. And
Thank you very much.
bye.
Thank you.
Bye.
All right, and we have 4 more awesome speakers to go. But before we start with the next one, just a 20-second break. And right back to DevOps and the second speaker of the day. He is senior software engineer at GitHub, has already 15 years of experience in the field, and this experience also fuels his channels, as he's an active podcaster and content creator. Welcome, Bazen.
Thank you so much for having me.
Yeah, thanks so much for joining, Bazen. Hope you're doing fine.
I'm doing great. I'm excited about this.
Yes. Regarding your talk, would you mind sharing a bit with the audience and me what we are going to learn from you today?
Absolutely. So GitHub Actions is something that a lot of folks are familiar with. A lot of companies have started adopting it. They're using it on a daily basis for all of their, continuous integration, continuous deployment workflows, so on and so forth. However, not a lot of people are familiar with a project called Actions Runner Controller, which is a Kubernetes operator that can help manage the management and orchestration of self-hosted runners on GitHub Actions. So today we're going to deep dive into Actions Runner Controller, but we're going to talk a little bit more about the architecture of it, how it works internally, and we're going to do a walkthrough of, the whole flow end-to-end.
Sounds very interesting, Bazen. You got my full attention, and I would say, without further ado, the stage is all yours.
Perfect. Thank you very much. All right. Awesome. Let's get started. So Actions Runner Controller. Actions Runner Controller was a community project, right? There's a need to manage self-hosted runners on GitHub Actions. And you need self-hosted runners sometimes because you might have, for example, on-prem environments or software that you'd like to use with GitHub Actions. It's not always possible to allow the GitHub hosted runners to access some of these resources. So you would want to manage your self-hosted runner yourself. And in order for you to do that, you would need some form of a solution that allows you to scale the runtime and have these self-hosted runners be created on demand, right? So the community has created an awesome project called Actions Runner Controller. It was owned and maintained by community members, Summerwind, Toastgear, Mumusho, and many others. And the solution grew in popularity to the point where GitHub decided to adopt it back in December 2022. And we brought this project in-house along with the community, and we started, building on top of this project. There's a lot of awesome effort that went into building the Actions Runner Controller solution, and how we manage it today is it's still ongoing. We are maintaining it, we are adding new features, and we want to make sure that this is something that you folks can use and make the best out of it. All right. Just before we dive deeper into the architecture and go into the design of this controller and how it works internally, I would like to show you a little bit how or what I'm really talking about, right? So on the left-hand side, you can see that I'm running a GitHub Actions workflow. This is a very simple workflow. It has three jobs that are going to be running in parallel. And on the right-hand side, you can see that I have a Kubernetes cluster that is already set up. And you can see that I have two components that are already running, the Actions Runner controller, as well as what we call the listener. And I'm going to explain a little bit more what these are. And when a workflow is being queued on the GitHub side, you can see on the right-hand side, I already have runners that have been created by this controller that are going to be taking over these jobs, and they're going to start executing them inside these runner containers that are running in my cluster. And this cluster is running locally on my machine. You can pretty much set it up anywhere you want, and you can use managed services like Azure Kubernetes Service, for example, to run your own cluster, or you could have your own in-house setup, and that will totally work fine. We currently support Kubernetes vanilla as is. We don't necessarily support OpenShift at the moment. And this is a fine way to use and scale self-hosted runners and to make them available for you on demand. So it sort of mimics the experience you would get with GitHub hosted runners, but this is a bit more managed in-house. Now, let us talk about Kubernetes. And let's do a bit of a deep dive, into the design elements of this and how it works internally. Because in my opinion, if you understand your tools at a very deep level of depth, then you can understand their limitations. You can understand also what they are very good at, right? And this is the purpose of this talk today, is to give you deeper insights into Actions Runner Controller. It's not necessarily a one-on-one on how it works. I have another video that I'm going to share at the end of this slide deck. It's a 2-hour deep dive into how to use Actions Runner Controller, how to set it up, how to configure it. That's not what we're going to do today. Today we're going to talk about Kubernetes operators, how you can create your own, what are the patterns that we've implemented with Actions Runner Controller, what works and what doesn't. So let's start with one of the most fundamental concepts that you have to really understand if you are both using Kubernetes or you are trying to build your own Kubernetes operator for whatever the problem that you're trying to solve with it, which is the concept of control loops. And the idea of control loops is coming from, control theory. So if you've taken any engineering course at university, you've probably came across this particular course, and some people like it, some people don't. But the idea is that the pattern of control loops has been introduced to Kubernetes. And in my opinion, it's a pretty smart thing to do, simply because control loops are fundamentally a way to maintain or to apply a certain desired state. So follow along here. I have a small slide, a state machine on the right-hand side over here, this is a small state diagram. And you can see here we have the white dot, which is the starting point. And we tell this control loop that we want a certain desired state. We want to apply a certain condition, let's put it this way. And that input is brought in. There's always in a control loop, the loop itself, right? Which in the Kubernetes world, we call it a reconciliation loop. And in the reconciliation loop, when it kicks off, the first thing it does is it does a check on a bunch of conditions to see if we have met the desired state or not. And if we didn't meet the desired state, we make an attempt to create the resources or to remove the resources or whatever it is that needs to be done so that we get to that desired state from whichever other state we are in. Okay. And then we try to apply these changes. And then we go into the reconciliation loop one more time. And then we check the conditions one more time. And if the desired state is met, then there's nothing really to do. We just finish, we exit the loop, we keep running the loop indefinitely, right? Because further input could be brought in by the users and the desired state could continuously be changing, right? So the reconciliation loop always makes sure that, or guarantees to a certain extent, that the desired state is met. And if it's not met, it will also alert you if it's impossible to meet that desired state after a certain amount of trials. So for software engineers out there, this is not necessarily a very foreign concept. We do this every day when we use loops. We check conditions. If the conditions are met, we exit. If they're not met, we try to reinforce or re-implement these conditions. This is the fundamental concept behind everything we're going to be talking about right now. So let us jump into the architecture of Actions Runner Controller and talk about how this Kubernetes operator talks with GitHub Actions. So on the one hand side, we have the Actions Runner Controller client or operator, which is running in your Kubernetes clusters, wherever they might be. And on the left-hand side, you have GitHub, which could be in the form of github.com or it could be GitHub Enterprise Server. It depends whichever flavor you are using GitHub with. Right? So you can see it here in this diagram. We have on the left-hand side our GitHub Enterprise, we have our repository, and we have a workflow already configured in it. I showed you this in the demo. And on the right-hand side, we have our Kubernetes cluster. This could be a managed cluster or an in-house managed cluster. It really depends, whichever option you prefer. Now, it's very important for you to be aware also something I really want to highlight and emphasize. A lot of folks try to install Actions Runner Controller in a cluster where they are running already production workloads. My advice to you is to not do that, okay? Actions Runner Controller or GitHub Actions in general is designed to run arbitrary code. So anybody can write any workflow and they can try to do anything on it, right? You definitely don't want to run these workflows in a cluster where you are already running production workloads that are way more predictable in nature. So if you are running your web apps, you are running your in-house solutions, you are running whatever other enterprise application in your Kubernetes cluster or any other production workload, you don't want this controller or operator to be installed on the same cluster because one, it needs a little bit extra permissions. Number two, these arbitrary workloads could create a noisy neighbor problem for you. They could impact the performance of the cluster. You never really know what your end users are going to be doing with it. So my advice is to always start fresh with a clean Kubernetes cluster that is designed and dedicated to run Actions Runner Controller. Now, with this disclaimer out of the way, let's dive a little bit deeper. So what is really happening? When you install Actions Runner Controller, and the way you would install it is using Helm. We decided to use Helm because this is sort of have become, I'm not going to say an industry standard, but it's quite popular in the industry. A lot of solutions that run on Kubernetes are using Helm. Helm is a templating system where we can basically create templates for how we want the resources to be installed in Kubernetes and how you can, what are the parameters that we allow you to customize and, tweak and change to fit your own specific environment. Now, when you install Actions Runner Controller using the Helm charts, the first thing that's going to happen is that the controller manager is going to be deployed, right? So the pod that will contain what we call the controller manager is going to be set up. And remember, we talked about control loops. Each one of these controllers is a control loop all by itself. And each one of these controllers is responsible to reconcile one specific type of resources. Okay, so this concept is very important for you to understand. In Kubernetes, you always work with resources or types of resources, whether there are some off-the-shelf types of resources that are available with Kubernetes when you install it vanilla, like, for example, deployments, services, pods, config maps, whatever it is. They come by default. However, when you are trying to extend this pool of resources, when you are trying to customize your own experience with Kubernetes, when you are trying to build on top of it custom controllers, you're going to need to introduce what we call custom resources through custom resource definitions. And these custom resources can be pretty much anything you want to define. What these are is a way to maintain a certain configuration with Kubernetes. So this is the way the end user is going to be able to communicate the desired state that the Kubernetes controllers, in this case, these 4 controllers, are going to try to maintain. So we can say, I want X number of ephemeral runners, I want X numbers of ephemeral runner sets, so on and so forth. And these Kubernetes controllers will try to guarantee that this desired state is met. And the way we're going to be able to configure these parameters is through these custom resources or custom resource definitions, through also our Helm charts. I know this is a lot. There's a lot of jargon that's being said here. I would love to take your comments and try to answer some of these and clarify them. But I'm also assuming that you already are quite familiar with Kubernetes and you already know some of this stuff. A lot of this is also simplified in the deep dive that I'm going to be sharing at the end of this session, if this is a topic you're interested in and you want to dive deeper into it. Now, we talked about control loops, we talked about controllers, we talked about custom resources and the relationship between custom resources and these controllers. Now we're going to talk about what happens after you install ARC using the Helm charts. So the first thing that's going to happen is that the autoscaling runner set controller is going to call our APIs, the API through api.github.com. And what's going to do, it's going to try to create, to fetch, the runner group IDs, because we introduced with Actions Runner Controller the concept of runner scale sets. And runner scale sets didn't exist before. We previously had only the idea of runners, so you can create your own self-hosted runners. We also had the idea of the runner groups. So you can configure a self-hosted runner, you can add it to a runner group, and with runner groups, you can manage which repositories or which organizations also could have access to this runner and which workflows could run workflows on that particular runner, right? Now, we needed something extra. We needed a way to create a pool of runners, okay? A group of homogeneous runners that pretty much look the same. And the idea came that we need to create what we call runner scale sets. And runner scale sets are fundamentally pools of homogeneous runners. They could have an indefinite size, and they basically can belong to different runner groups, right? So this is the whole fundamental idea that facilitated the development of Actions Runner Controller in a way that is way more reliable and in a way that allows us to scale up and down self-hosted runners in a more predictable manner, right? On more operationally ready or production ready manner. Now, runner scale sets are fundamental to this whole thing. So, and runner scale sets, as I mentioned, can belong to runner groups, because you need to define which repositories can access runner scale sets and which workflows can address runner scale sets. Now, one important thing about runner scale sets as well is previously you're familiar in your actions, in your workflows, you could use labels to say that this workflow needs to run on these particular runners that have these particular labels. However, with runner scale sets, labels are not supported for the main fundamental reason that runner scale sets are homogeneous in nature. So the runners belonging to them are all pretty much the same. If you want to have different runner sizes, different runner base operating systems, different runner configurations, you need to create multiple runner scale sets, right? And these runner scale sets cannot have multiple labels. They can have a single name. And that is how you define how you want your workflow to run on that particular runner scale set. Now, when you say, I want my workflow to run on a runner scale set, you're not necessarily specifying which exact runner you're going to be targeting. You're going to say, I want to target this pool of runners. And then the client that's going to scale and create these runners for you, like our Actions Runner Controller in this scale, is going to make a runner available, and then any runner that is available to pick up a job is going to be picked up. So you cannot really target that specific runner. You can just target the pool. And then when the pool makes, or the client makes these runners available, you can the workflow will run on that particular runner. You're going to see it in this diagram a little bit. So we fetch the runner group ID, and then the auto-scaling runner set controller one more time calls the API to fetch and create the runner skill set, right? So the runner skill set, this pool of runners, did not exist before we install Actions runner controller. When we install it and when we provide or supply the configuration, the Actions auto-scaling runner set controller, which is here in this case, is going to be the one that calls the APIs to create the runner skill set on the GitHub side, right, on our backend. Now, at the same time, it's gonna be responsible also for, or the auto-scaling listener controller is gonna also be responsible for creating what we call the runner skill set listener. And the runner skill set listener is very important because this is the main entity or the main thing that's going to be making the decision on how many runners we need to create and how many runners we need to reduce. So that's going to make the decisions on the scaling up or down behavior. And after we install Actions runner controller, this listener pod is going to be created, and in this listener pod you're going to have one container which is going to be running the listener application, which is going to make all of the decision making. Now here it's very important, this application that I talked about that's running inside the runner skill set listener pod is going to create a connection back to the action service on the GitHub side. And when it creates this connection, it's going to create a long pole HTTPS connection, and it's going to authenticate with the credentials that you already supplied with the Helm chart. Once it authenticates and it creates this long pole, it's going to wait and it's going to listen for messages that are going to be coming in from the backend. And it's just going to make sure that whenever we receive a certain message, that it is acknowledged and further steps happen. So the listener is very fundamental to this whole equation, and it is where the logic resides when it comes to us scaling up or down. Okay, so let's take an example right now. The setup is done. The resources are, created. Let's go through an example of a workflow. We run simple ci.yaml, which is doing not much. It's just, running as a workflow dispatch. And then it runs on our runner skill set, which we provide the name of over here. And then it's just simply saying echo hello world. Nothing fancy, very simple workflow. When we trigger this workflow run on the github.com side or GitHub Enterprise Server, a message is going to be received, or it's going to be dispatched from the action service backend through the long pole connection to the runner skill set listener. And when the listener receives this message, it's going to also receive a bunch of statistics, because you could be running multiple workflows in parallel, right? We need to make sure that we scale to the adequate number. So the listener will receive this message, and the listener will check the current state versus the desired state, right? It's going to make some calculations. It's going to see how many runners do I have available running right now? Do I have any of them? Do I need to create more? Do I need to remove some of the runners that have been finished? What do I need to do? The listener makes a decision in this case, because we have no runners, because it's a fresh setup, right? To add one more runner to fulfill this workflow run that has been created on the GitHub side. So what the listener will do is, in this case, it will patch. I'm going a little bit into the details here, but it's basically going to patch the ephemeral runner set resource, and it's going to say bump up the number of runners that you have in your pool by one more. And then what's going to happen is that the ephemeral runner set controller, the ephemeral runner controller is going to try to create these runners. It's going to try to create runner pods that are running the runner container, right? And that runner has the runner binaries which we publish, and that runner is going to be responsible for picking up that workflow run and executing it. Okay, so the listener did its job. It made the decision to bump up the number of runners by one. It patched the necessary resources, and now the controllers do their job by going into the reconciliation loop and making sure that we match that desired state. And that is how the runner pods are created. Now, when the runner pod is created, it is not given a job ID or something like that. What happens is the runner, when it starts and when it launches, it is provided with the necessary credentials. We create what we call a just-in-time token, which we provide to the runner. This is also enhanced security. We don't provide your personal access token or any other big credentials to the runner. We just provide it with a very fixed scope token that it can use to call the actions backend service through the step number 8 you can see here. And then it will say, hey, I'm available now. Do you have any jobs assigned to me? And then the actions backend will check its pool of workflow runs and say, yes, I have a job that has been acquired by the runner skill set listener in this installation. And now this job is pending a runner to go online and to pick up and to be assigned this run or this particular job. And the action service is going to assign at this point the job to the runner. And the runner is going to take this job and it's going to make an attempt to execute it and also report back on everything, the logs, the status of the workflow run or the job run. And it's going to report back any errors it sees, so on and so forth. That's pretty much it in a nutshell. It might seem a little bit more complicated than it is, but that is the state of that is the problem we have to deal with whenever we are trying to do reconciliation work between distributed systems in a way, because these are distributed, right? We really don't know, and we cannot really control the actions runner controller's behavior. We can just simply give it events, and then the actions runner controller is going to try to respond to these events as it receives them from the GitHub backend, right? Now, when the runner completes its job, the controller is also responsible. It finishes, so it exits, and then the pod will be gone. And at that point in time, we go into the reconciliation loop one more time to check if there's anything that we need to do. Maybe there's some cleanup that needs to happen. We check the desired state versus the actual state of the system, and we see if we need to, scale up or down or do whatever the necessary changes are in our cluster. All right, I know this is a lot, but that's what goes into Kubernetes operators. That's why sometimes they have a little bit of a flaky behavior, because the work that is done in a Kubernetes operator is not very much deterministic. There's always some reconciliation that has happened. So it sort of implements a sort of a eventual consistency model, right? So eventually it will be consistent, but you can never really force. So the actions backend can never really force action runner controller to do something, and actions runner controller cannot really force the backend to do something. All what they can do is they can exchange events, and then both of these systems are going to make an attempt to get to that desired state and maintain this desired state. So that's why things can become a little bit complicated, when things are happening, especially internally. All right. We talked about the high-level stuff. We talked about how things work. What I would love to talk about is the code. So we have a little bit of time. I would love to show you how all of this looks in terms of code and where we are managing this project and how we are running it, because this project is open source. So pretty much anybody can go read the code, learn from it. And maybe even if you have some great ideas or fixes, you can contribute them to our open source project. All right. So I'm jumping here to github.com. And I'm jumping specifically to the repository that's called Actions Runner Controller, and it is hosted inside the Actions organization. This is where we have a lot of other, tools already open sourced. We have the runner, that the self-host, the runner binaries, they are open source there as well. So you can go inspect them, read them, understand how they work. And you can see here the Nicola is one of our biggest contributors to this project. This is sort of his baby in many ways. He wrote a lot of the code for Actions Runner Controller. He has done a fantastic job on it alongside the rest of the team, which are way too many to count over here. They've done an amazing work over the past year or so, trying to get this project off the ground and to make it as reliable as possible, because we know that a lot of these workflows are quite important for organizations, and the worst thing you would want to do on a day is to block your developers from being able to do their work, and systems like this become very, very business critical. All right, so what are we seeing over here? I'm not going to go over this folder by folder. Of course, I'm just going to highlight some of the essentials or the important aspects of this project, and I'm going to show you a little bit how everything works. What you also need to understand is that there is a bit of a difference. When we took over this project from the community had built the solution in a certain way, but that way was a little bit suboptimal for a couple of reasons. The way the community built the old solution was to rely on what we call webhooks or webhook events. And also they could rely on API calls, but that these API calls were not really designed for the purpose of automatic scaling like this. Now, webhooks are slightly unreliable sometimes for the reason that the webhook delivery could fail. It's sort of ephemeral in a way. If you missed to process a webhook event, you cannot really repeat it. You need to go to the UI and specifically find that event and try to re-trigger it. There's no guarantee that webhook event has been processed successfully. If you have some parsing error that's happening on the client side, you might have problems. These are all resolved with Actions Runner Controller for a couple of reasons. The long pole connection that is created between Actions Backend and Actions Runner Controller is sort of a guarantee. And if that connection breaks, then the controller is not going to acquire any more jobs, right? That is a big signal that something has went wrong. And the jobs are going to stay in a pending state on the GitHub Actions or GitHub Actions side, right? Waiting for the controller to acquire them and acknowledge them. Right? As opposed to webhooks, which are just sent and whatever happens, happens. If you have a failure of some sort, GitHub will not know about it. Okay? So this is much more reliable as a solution or as a way of working. And we decided to keep the old modes because a lot of enterprises haven't had the chance to explore the new ways of working or the new modes. And we wanted to also give the opportunity for folks to migrate. And maybe there are some use cases still for the old modes that are, not necessarily made redundant with the new solution. So we wanted to give the community and the other organizations an opportunity to migrate. So once we start seeing that the usage of the old modes has completely been reduced, we might decide to deprecate them at some point down the line. But until then, the community is still responsible for maintaining them. This is not something that GitHub maintains. We just maintain the new mode. And if you'd like to understand a little bit what I'm talking about when it comes to new modes and old modes, you can just jump to this discussion forum over here. You can go to announcements. And if you go to this post that I wrote a while ago about auto-scaling runner sets is made generally available, I discussed at length what are the modes and assets that are supported by GitHub versus what is everything else that is not supported and that the community is currently maintaining. Now, to understand what these assets are, we have to go through the repository, which we're going to do right now. All right. The first thing you need to understand a little bit is, you remember at the beginning, I talked about custom resources. So how do we define these custom resources? How do we tell Kubernetes that we need to create a new set of resources for you or for our custom controller to manage, right? And by the way, sometimes I use the term controller and operator interchangeably because in my mind, the controller is what's doing all of the work. And it's sort of not behaves, but like it is the operator in many ways. So don't get confused by that, right? When I say operator, it could be one or multiple, it could be the combination of one or multiple controllers, okay? All right, so if we go to this folder, you're going to see the first thing is that we have two distinct folders. One of them is namespaced with actions.github.com v1 alpha, and then you have something else called actions.summerwind.net v1 alpha. So the actions.summerwind.net contains the list of resources that have been created by the community for the previous solutions or for the legacy modes. Okay. When we started our work, we created a new namespace and we wanted to create our new unique set of custom resources, which are available in actions.github.com v1 alpha. Now, if you go to this folder, you're going to start seeing that. Oops, sorry. You're going to see the different types of resources that we are going to make available. And I want to do something extra over here. So let me open up this view. I'm going to go to docs. I'm going to go to GHA runner scale set controller. And I'm going to go to the diagram, which we just seen. This is the architectural diagram. I'm going to put it on this side over here. And I'm going to zoom in to this segment. And what I want to do is I want you to compare the code that you're seeing on the left-hand side with the controllers that are on the right-hand side, right? So you can see here we have the auto-scaling listener, which is going to be managed by the auto-scaling listener controller, right? Remember, I mentioned each controller is responsible for reconciling one type of resources. Then you have the auto-scaling runner set, which is managed by the auto-scaling runner set controller. Then you have the ephemeral runner, again, ephemeral runner controller, and then ephemeral runner set, which is managed by the ephemeral runner set controller. And of course, yeah, that's pretty much it, right? And if we just open any of these, you can see here there's just a definition of the type. So each auto-scaling runner set listener, or auto-scaling listener in this case, has a bunch of properties. And these properties can be configured. They have a specific type. They have certain conditions, like when you configure the GitHub URL, the secret, the runner scale set ID. Some of these you configure them yourself. Some of them we populate them ourselves with injected configurations. You can also specify for each runner scale set installation that you have a maximum number of runners or a minimum number of runners. So this is an upper and lower boundary for your scaling. Obviously, you don't want them to scale indefinitely, but you do. Sometimes it depends really on the resources you have on your cluster. You can also configure which container image you're going to be running, because these controllers, the way they work is you're not necessarily running an application how do you say it, like as a binary in your Kubernetes. When you install a Kubernetes operator, it runs inside a distinct specific pod, but that pod is running a container. So the way we publish this operator is through a container image, which is running the controller manager application, which is composed of these 4 controllers. So this is more of a logical diagram that explains the different elements, but they are all running within the same application that we ship as a single container image. So you can also here specify which version of that image you'd like to use, so on and so forth. You could also configure a lot of stuff, like in a lot of environments, you have a reverse proxy to connect to the external world. You might have some, TLS configuration that you need to specify. You might need to inject some certificates, either in the listener so that I can communicate with the, with GitHub. This is particularly useful for GitHub Enterprise Server, or you might, you have some internal certificates necessary to go through an intermediary proxy for you to get or reach the internet. It really depends. There are so many different variations for enterprise environments. So yeah, this is pretty much how we specify what this resource is and what are the fields necessary to configure it. I'm not going to go through all of them, obviously. I just want to give you like a taste of, the whole thing and the whole setup so you can navigate this repository a little bit better. Let's maximize this again. The next thing I want to talk through is the controllers. So if I go to the controllers folder, this is where you're also going to see another, namespacing here. So we have the 2 folders. Obviously, we're going to jump to actions.github.com. And you can see here that we have controllers with the same name as the resources I just showed you. Why? One more time, because each controller is responsible for reconciling a specific type of resources. Now, there's also a bunch of other stuff like tests unit tests for our controllers. We also sometimes have a bunch of helper functions that we need to do some of the work. We also are exposing metrics for the internal behavior of this operator. So some of that is defined in the metrics folder and in other places. and not folder here, it's like the metrics package. But yeah, let's take this as an example controller just to show you. So if you see here, we're just importing a bunch of packages. We're defining some structs that we're going to need. But the main fundamental thing we're going to always be coming back to is this function. This is the reconciliation function, which is always going to run whenever we enter a reconciliation loop. So if you remember my state diagram at the beginning, right, I showed you that we have this reconcile loop over here. This is pretty much it. You go to this controller. This is your reconciliation. Oops, sorry about that. This is your reconciliation function. And in here, we are reading a bunch of properties. We are calling the Kubernetes API to fetch the current state. Tell us, what do you have in terms of resources? Where are our resources, right? What do we need to do about those? We are running certain conditions. Sometimes we have to delete resources and to do some cleanup work. Sometimes we have to check what is the current state. Is there something that needs to be done that we didn't do? Sometimes we have to manage conditions, like, for example, what happens if we fail to find the configuration? What if someone jumps in and does some manual edits in our Kubernetes cluster, and it puts us in a recognizable state? We have to fail, or at least try to get out of these bad states. This is why this stuff gets a little bit complicated, because there are so many different variables that can come into play. But that's the gist of what we are trying to deal with over here. We also check if we have all of the necessary resources that we have, and that we have the secrets, everything that we need, that we have the necessary roles and permissions to be able to create resources. There's a lot of other conditions that we need to check. And now here's the magic where it happens. Whenever a change in the desired state happens, we compute what we call a hash, a spec hash, right? And that is it goes through a hashing function. And obviously, as you know, if you change the input of a hashing function, you get a distinct output every time. But if the input is still the same, you get the same output. So this is how we do sort of a check whether any of the configuration has changed. And if anything of the configuration has changed, we try to apply the new configuration as it is been supplied or provided. So if you've been asking, how does the reconciliation loop understand if a change happened? This is how it's done. A change in the desired state. And then obviously we apply a bunch of other configurations. We make sure that the state of our resource is stable. And here you can see the listener pod. This is the resource we're trying to create, because this controller is responsible for creating and making sure that the listener pod is always running and it's always in a healthy state. And that's it. This is how controllers work. Anything else you see in this controller file, that's pretty much some functions to do very specific things, cleaning up, maybe even creating some of the resource templates that we need to use to call the Kubernetes APIs, injecting environment variables sometimes. But yeah, that's like, let's say, configuration work, and these are all sort of helper functions in many ways. The reconciliation loop is the most important element in all of this, and now we're just going way too much into the details that I don't think are necessary to understand how this operator works sort of end to end. All right, now let's go back, exit the controllers folder. One more thing I think that is very important. If you remember when we talked about sorry, I need to jump to the architectural diagram one more time. Let's go here. Docs. Oh, I already have it. Never mind. So you remember we talked about the listener pod over here. The listener pod is obviously running a distinct application. And it's very important also for you to be aware where this application resides. So if you go to the folder command, CMD here, you can see we have something called Actions or GitHub Runner Skill Set Listener application, right? We adopted the same pattern that the previous controller used. That's why you can see it over here as a distinct application. This is deployed through the same container image that deploys that we're using for the controller manager or the controllers. So they are bundled together. But then when we start these applications, we provide different parameters to tell this application, oh, now you need to run the listener, or now you need to run the controller manager, which contains all of the different controllers. Now, when it comes to the listener, obviously the main.go is the entry point, and the listener is a simple web server. Or in this case, it's a simple web client, actually, because the web server is going to be on the Actions backend. And this web client creates a long pole connection with the Actions backend, a TLS connection, right? Long pole. And it's going to go into an indefinite or infinite loop, waiting for, as I mentioned, messages to come in, right? So if we call the listen and serve, I think this is the definition over here. Yeah, there it is. So we are starting an HTTP server, and yeah, when we run, we are starting an HTTP server, and it's just gonna create a long pole connection through the configuration we supplied, and it's just gonna wait for messages. Now, when messages are received, we are processing those messages. I think it's over here. We are processing these messages, and we are, yeah, there it is. And then we are trying to determine what we want to do with these messages. And then we need to make a determination. Do we need to scale up? Do we need to scale down? We need to acknowledge these messages. Also, we need to delete these messages. I don't want to go too much into the behavior here. I just want you to understand that this is how the listener server works or behaves. And this is what it's trying to do. And then when it acquires a certain job, it just simply tells the Actions backend that, hey, this job is mine. Can you please assign it to one of the runners I'm going to be making available for you? And the Actions backend is going to try and make that happen. So all of this logic is in the GitHub runner skill set listener folder. We also have extensive tests, mocks, and everything needed to make sure that this listener is operating the way it should be. And these are pretty much it. These are the main components of Actions Runner Controller. Everything else is just, packages either for the legacy mode or stuff that is needed to test, run, manage, and operationally manage this entire project. Now, in terms of packaging and publication, that's the last thing I'm going to be talking about before I, start going through a Q&A. I'm pretty sure you have a lot of different questions. Maybe even I went a little bit too deep for you to be able to formulate adequate questions. But yeah, we will see. So the idea is whenever we create a new version of Actions Runner Controller, we are publishing a bunch of things. We are publishing mainly the Helm charts. Well, forget all of those. A lot of these are private, but I'm already authenticated. That's why you're seeing them. So I just want to show you the important stuff, which are these. So when we create a new release, you can see it here in the folder, obviously, that we have a new release in our releases. So the latest one is called GHA Runner Skillset 0.6.1. If you go to the releases, you will also see other stuff. You can see stuff like, Actions Runner Controller 0.23.5. These are legacy modes. So these are still the legacy releases. Again, we want to maintain them because people are still using them, as you can see here, right? However, the new ones are all labeled with GHA. So wherever you see GHA, GitHub Actions, that means this is the new stuff. And the latest release is 0.6.1. We are trying to work on the 0.7.0, which is going to include a bunch of features that are going to improve also the behavior of this workflow. Now, when it comes to the Helm charts, we are publishing them as OCI compliant images, as opposed to publishing them through GitHub pages. Whoever used Helm charts before will understand this distinction. We want to use this way because we believe this is the right way to publish Helm charts, as opposed to publishing them through GitHub pages, which was never intended or designed for that particular purpose. sort of is a workaround or a hack. Nevertheless, this is it. It's not a Docker container. These are the Helm charts. So if you download this image and you unpack it, because at the end of the day, fundamentally, what are container images? They are sort of tarballs. That's it. Even the complicated images and whatever, they are fundamentally tarballs containing everything that is necessary for you to run a certain thing. So this is the GHA runner skill set Helm chart. We have 2 Helm charts, and then we also have the controller Helm chart. And I'm not going to go through into the installation steps and why we have 2 Helm charts. This is again left for my deep dive video, which I'm going to share the link in the presentation deck in a bit for you to go and check it out if you are interested in this project. But yes, we have 2 Helm charts that we package and publish. And then also these Helm charts will pull this GHA runner skill set controller. This is a container image, which, as I mentioned, contains the application that runs the controller manager as well as the listener. And it's just bundled in one container image that the Helm charts will pull. You obviously can see here that we have multiple releases, and we also publish canary versions. So this is basically our nightly build. Whenever we merge anything to the master branch, if you want to test the latest and greatest, if you are waiting on a patch that hasn't made it to a release yet, you can run the canary image just for testing purposes. We don't recommend that you use it in production because our main branch is not always in a stable state, even though we try to maintain it as such. All right. This is it. I talked a lot, to be honest. I hope it was useful, but I just wanted to give you a glimpse of this project and the code base and what's really happening here. There's a lot of work that goes into maintaining and publishing this solution. And the last couple of thoughts I have here. So let's go back to the code slide. Last couple of thoughts is the video I mentioned that is a deep dive for how to use Actions Runner Controller. You can find it on this link, tinyurl.com/arc-deep dive. And this is my own YouTube channel. This is a 2-hour shows you all of the different aspects of running Actions Runner Controller, the different configurations, the knobs, the twists, so on and so forth, so that you can be successful and that you avoid contacting us to help you with your setup. We have all the information necessary for you to get up and running. We have also published extensive documentation on github.com, which you can go and check out yourself if you want to run the solution in-house. All right. That's it from my end. I think I am ready to take on some questions if the audience has any questions. I really want to thank you for your patience and for sticking with me if you've stuck with me for so long. I hope I didn't confuse you too much, and I hope by the end of the session you understood a little bit more about how Kubernetes controllers are built, how they are designed, and specifically how Actions Runner Controller is designed and published. Benedict, back to you.
Hello again, Basem. Thank you so much for the very informative talk. So it was really a deep dive. And to the audience, if you're interested in more, we also posted the link in the chat. So it's you're just one click away from diving even deeper into this topic. And Basem, we still got some minutes left, some time for some questions. If you're ready, we can start right away. And so you got 15 years of experience in the field, I read in your bio, and you certainly enjoy also talking about it and teaching others. But I'm a bit interested in your own developer journey. Where did you start it out? Why and when became you interested in tech? And in particular, of course, software development.
That's a pretty long answer. I'm not sure how much time we have, but in short, I was always fascinated with computers. I started writing code when I was 12 years old. My uncle bought me my first computer. It was a gift because my parents didn't really, understand why they need to pay so much money for a toy. They thought it's a toy. But yeah, I spent a lot of time hacking back in the day. And then it just consumed me fully. I was so obsessed with computers that I studied computer science at university, but I never completed my education. I dropped out. And I've been working professionally since I was, 15, 16 years old, trying to build software for other folks. And I've been doing it ever since. I am now 34 years old. And it's been a long journey. I learned a lot.
Yes, thanks for that. When it comes to the parent part, the trick was always, yeah, it's for school. It's for school. But
Exactly.
after some time, they get behind it and say, oh. I think we all went through kind of the same story there.
I'm sure.
So let's tackle some of the technical questions that came up. What challenges can come up when scaling self-hosted runners in Kubernetes environments, and how does RLC effectively address these challenges?
Great. So some of the challenges are the ability to scale up very quickly and the ability to scale down to zero very quickly as well. And the problem with that ARC is specifically trying to address is to scale to meet the demand, right? So you don't have to overscale and you don't have to underscale. What ARC is always trying to do is it's trying to create enough runners to match your peaks and to also scale down whenever you're not really using, or whenever your group of software engineers are not really hitting GitHub Actions quite hard. And this is the problem that fundamentally ARC is trying to solve. Now, if you ask me my opinion as a technologist, is Kubernetes the best environment to run this type of workflows? Maybe not, just because I think the isolation that virtual machines provides, and this is the philosophy that we adopted when we published GitHub Actions. We think runners need a little bit more resources. They need to overcome a little bit of the limitations that are imposed by Kubernetes clusters. However, Kubernetes is a popular technology, and a lot of people felt that this is an adequate area to run these types of workflows. So we said, yeah, okay, let's give it a shot, and we are trying to resolve some of these problems. You're going to see a lot of issues when it comes to running containers, for example, within workflows. So we have solutions for this, like running Docker in Docker, or using container hooks to run these workflows as other pods in your Kubernetes cluster. But again, these also bring in some complications, because some of these require you to run these workflows or pods in privileged mode, which is not always a go for a lot of different enterprises, especially if you want to try to lock down your Kubernetes environment. You might also bump into some resource limitation issues. You might need to be very careful how you size your cluster, how many nodes you make available, how you define the limits, resource limits you provide for each one of your runner containers or runner pods. But we have some solutions for many of these problems. You have to have a lot of Kubernetes experience before you run this project. This is not easy. And if you are starting from scratch, you might need to ramp up on your Kubernetes knowledge before you dive deep into ARC.
So no beginner's topic for sure.
Definitely not, no.
But maybe you also have content for beginners on your channels. So
the deep dive covers that. But I would say also maybe taking in a Kubernetes course or like some fundamental Kubernetes knowledge before we dive into this realm is definitely highly recommended.
All right, thanks for clarifying that. Kind of connected to this and more like maybe a career question. The question came up from one of our attendees: do we really need a degree to get a job as a software developer? And if not, what do we really need to cover as a self-taught programmer? Like what languages, technologies, algorithms?
Wow. I've spoken about this and I keep speaking about it all the time on my channel. I've had many guests and I've spoken about it myself. I even have videos about how far you can go as a software engineer without a degree. And I've delved into this, into the details and intricacies of these problems. Let's put it this way. A degree or going through university and learning computer science topics helps you refine your knowledge about software and programming in general. Before I went to university for a couple of years, I didn't know anything about algorithms, data structures, and topics like that. And I felt like my job as a software engineer is just to make things work. The elegance of the code, the cleanliness, operability, maintainability, scalability, all of these problems were never occurred to me before, right? Before going to college. So it's very important to learn these fundamentals, even if you are a self-taught developer. It's not just about picking up a programming language or a tech stack and just running with it. You have to learn how to write code, especially if you're doing it at a professional capacity. that code that is maintainable, code that is designed to solve problems, code that doesn't create more problems than it solves. And these are all things you either gain with experience or you have to take courses to learn more about. Also, understanding the tools you use at a fundamental level is very important later on in later stages. You could get by in the first 4 years of your career, maybe even 5-6 years, depending on the market you are in, by just being a sort of a generalist, not understanding the tools you're using at a very deep level. You can get by just making things work. Other people are giving you tasks and they are creating the work sort of for you, and all you have to do is just to execute and make things work. However, as you progress in your career, and if you get to senior level plus, you have to understand way more details about what you are using on a day-to-day basis, and you cannot take anything for granted. You have to understand how databases work, operating systems, how they work. You have to understand the limitations of these tools. And just like we did a deep dive right now about Actions Runner Controller, deep diving into these tools is very, very, very important for you to progress and become, a master of this craft, as I like to call it.
Thanks for that answer as well. Since you talked now a lot about the fundamentals, maybe as a closing question, do you have any additional resources you could share with the audience on how to get into tech or your stack in particular?
I have a bunch of videos. So if you go to my channel, it's glitch.stream, but glitch, write it without a T. I thought it's funny to write it that way, but anyway, or just Google my name. You're gonna find my YouTube channel. I talk a lot about these topics. I even have commentary on the developer roadmaps for senior developers, staff engineers, so on and so forth. And I also have in my podcast a lot of guests where we talked about breaking into tech. I brought in guests who have entered into this realm through so many different ways, and there isn't really just a unique way to break into tech. There are so many different mechanisms to do that. And don't worry, the imposter syndrome hits everybody, even some of the more senior of us. I face it every day, but all you have to do is just to keep learning and keep growing. Just face the challenges head on, and just enjoy the ride. That's all I have to say.
Enjoy the vibe. What better ways to close a session like this? Basim, thank you so much for joining us today, giving this very informative talk and also this very good information also for maybe younger or newer developers, that is. To the audience, make sure to check out all his channels. We will post them in the chat for you. And Basim, hopefully see you next time on another live day.
Definitely. Thank you for having me.
Thanks so much. Bye.
Bye.
So, and before we jump to the next speaker of the day, just a 10-second break. And right back to DevOps and the third speaker of the day. He is product owner at Stadtwerke Cloud Foundry. His professional background includes multiple roles. For example, enterprise IT architect, DevOps engineer, cloud counselor, and Scrum Master. And currently he focuses on customer success with platform as a service. Very welcome, Maurice.
Hi, thank you for having me.
Hi, Maurice. Thank you so much for joining us. Maybe as a first, could you share your screen right away so we can jump into the session right after the intro?
Sure. Just a second. There we go. I'm a bit late on this, sorry. So now you should see something.
Perfect. All there. Thank you so much, Maurice. And before we start now with your talk, would you mind sharing a bit with the audience and me what your talk is about?
Yeah, so my title is a bit, I like Kubernetes dev is fun, but setup in ops isn't. So I'm sorry if this is offensive for anybody. So this is not my intention. I just would like to grab your attention for a few minutes to see if you are figuring out the same stuff and if you would also wish for an alternative. So that's basically what it is about. So it's about Kubernetes a bit, but more also about a nice alternative that you could also consider.
Yeah, a very attention-grabbing title, I have to say. Hopefully we don't have a flat-out war at the end of your talk, but let's have a look. Maurice, the stage is all yours.
Thanks a lot. So yeah, so I can fast forward on the introduction. So my name is Maurice, product owner of Stadtwerke Cloud Foundry. I'm 38 years old. I like mountains and clouds and all this kind of stuff. I'm from the Schwarz Group, and I'm mainly focusing on Cloud Foundry. And whenever I say Cloud Foundry, I mean open source Cloud Foundry. So also something you can consume. Stackit is basically a cloud provider, but I don't want to do the commercial stuff here. So just that you know what this term is all about. And it's the cloud brand of Schwarz Digits, which is the brand new IT division of the Schwarz Group with 7.5 thousand employees just in IT. Schwarz Group is a bit bigger, has more revenue than IBM and Bosch combined. So that's basically where we are and why we build our own cloud. But this topic is now, I try to remove all this part from my presentation to focus more on the content. So as I said, I would like to see or to share my insights on an alternative solution, because this is actually me when I look at Kubernetes and trying to figuring out the same or solving the same as I do with Cloud Foundry. But you might have a different level of experience. And actually, this should not be a talk about Kubernetes or Cloud Foundry exclusive, or because these platforms are really also different. So Kubernetes is more, here's my app, run it exactly how I want it. And Cloud Foundry is more, this is my app, run it, I don't care how. So in the beginning, so it's a nice starting point, but it's not an exclusive, mutual exclusive stuff. So I would like to show you how it really feels, what Cloud Foundry is, how it compares, what are the main differences between Cloud Foundry and Kubernetes, and also in matter of speed, like how much can you do in 5 minutes when it comes to deploying apps and putting things into production. So that would be my main focus, the timing thing, but maybe first a bit more about platform as a service. What is it and what is it not? So most of you might think of containers when it comes to platform as a service, but this is a good direction, but this is of course not all of it. And why is that? So I dig a bit deeper into this, but not too much, because I don't want to start with on-prem stuff where you have to deal with servers, hard drives, SAN, LAN, internet service providers, and all this stuff on your own. Most likely you nowadays go to your own IT department that serves virtualization, or you go to a cloud provider or one of the biggest hyperscalers to consume virtual machines, right? Where you get all the yellow parts already managed and you don't start really from scratch. But this means also that if there are severities in your components, and if you work with quite some components in the past, you have experienced some of these vulnerabilities and how fast you have to react, then you also know that this is not that much fun. So you might need or might want to manage as less as possible as or you have the least amount of components in your own control that you have to manage and you have to deal with when there are some vulnerabilities. And in platform as a service, you as a developer, you just care, or as a DevOps engineer, you just care about your application and your data. and all the rest you can consume from a provider. And this is where also managed paths comes in. And let's have a look. What are some example services that you can consume when it comes to infrastructure as a service, IaaS? So this could be managed OpenStack, but also from the hyperscalers, their own VM types like EC2 or so on. And managed Kubernetes or container as a service is somewhere between infrastructure as a service and PaaS, because sometimes you get some portion of OS and some other services on top. But basically, you also have, as a developer, to handle your runtime. Whereas if you use managed Cloud Foundry or other managed application PaaS solutions from the public hyperscalers, for example, then you just deal with your application and your data. And if we now draw the line of your container that you run your application with, then it becomes a bit more clear that in one case, you have to deal with all these vulnerabilities and stuff in your runtime, and on the other side, parts of that is included in the service that you consume. So now let's directly jump in a demo what it feels like to consume such a service. So let's have a look if this demo works. Just have to grab my right browser. So first of all, I log in to get a fresh token to the solution. So for example, here in our dashboard, we have Kubernetes and Cloud Foundry all together. You can create an organization, which is just how you organize your apps in the end. And with that, you also get a login URL where you can log in with a one-time token. And then you're basically in it, and you see all your organization. I now choose Maurice external and the demo space. And as we can see, I just have some cron tests here, but no nice web app. So now I would like to show you how the simplest possible app I can think of can be deployed. So we see we have 11 minutes past the hour. So let's start. I am creating a directory, for example, devs. The file exists, nice. And a new one. So this is empty, as you can see. I now touch a file, which is the static file, to indicate that I'm now dealing with a static web project to begin with. And now I just say, hi devs. And I put this in a simple index HTML. This is the easiest web project I can think of. And then I just say cf push for Cloud Foundry, push this app and call it hi devs. And now what Cloud Foundry does, no matter if you have a very simple app or a very complex app, it just takes whatever is in your working directory and uploads it. Then it looks at all the programming languages or container images it supports, and it finds out that this is just a static web project. So it just installs an Nginx in a container, binds a route to it. So a DNS name is created, and in the end, it shows the app is running with one container. So let's have a look how this works. And I now use this URL. It also, you will notify, I also have a valid SSL certificate. It directly jumps to HTTPS, and I have this hi devs command here. Now, to show you that this is really the app, I can also scale it down. And by the way, we just spent 2 minutes on this right now. So now I just scale it down to 0 instances. And now when I refresh, the app is not found anymore. But the same way, you can scale it up to 5 instances, of course. And as you know, with other container management or orchestrators, of course, this is super fast, and your app is running again. But this is maybe not so interesting. So let's maybe look at another example, because I also teased a bit that you cannot just only push code, you can also push data or anything else if you use these concepts here in a creative way. So, and if you are less busy with operating all this stuff, you can come up with some other ideas. So now I use the UI part to deploy something to Cloud Foundry. This UI is also open source, so you can also use this. So I choosing my organization and my demo space once again. And now I chose GitHub, so I can use any kind of GitHub org or project. So I created something called FunCF, where you also find this very easy Hello Static app that I just created. But I also have here a Hello Weather app, which is built on Python and extends the Hello World with some weather information. So let's try this. You can even pick the branch and the commit, but I just keep it as it is, and I override the name to be, I don't know, hello or sunny hello. Click on deploy, and then it works the same as in the console. And if we are lucky, within our 5 minutes time slot, we deployed already 2 applications. Well, but deploying just apps is not the biggest advantage of PaaS, that this is fast and easy to operate. It also includes, if you see the term marketplace, other services like databases, so that you can order, for example, a Postgre database or something, or a message queue, and then bind it to your app, and then your app gets automatically all the credentials injected via environment variables, so that you as a developer don't have to deal with any kind of secrets. And if you use, for example, Java applications with the Spring Boot framework, then Spring Boot will automatically detect these environment variables and get the credentials to your databases out of the box, because it's tightly integrated with Cloud Foundry. All right. So this takes a bit longer as more dependencies are included, but let's have a look. It's not started yet. All right, but maybe I just continue with my slides a bit to show what happens behind the scenes as we watch the demo. Just now I have to move away the browser to see. It's a bit tricky because my screen sharing is also in the browser. Sorry for that. So, but now, yeah. So once again, all these demo apps, if it's too fast for you, I also included all this in this GitHub repository, so you can also have a look at all the other examples. But now, and if there's some time, we can also jump back and look into it a bit more. So what happens behind the scene when you push an application here? So in order to work or to be so easy for the developer. The platform is a bit more complex in the background, of course, but explaining all these components in detail will take too much time. So I will now focus first on this Cloud Foundry push command, and also on, even if there are some APIs that you can use, an integration to pipeline tools, and this UI that we saw. I would focus now on the command line interface, because it shows also nicely what options you have and what works with Cloud Foundry. So this CF push command, as you can see, it did all the job from the uploading the code until setting everything up and running the app in the end. But you can do all these intermediate steps also manually. So basically, first there's an app created. And as you can see, the app is also just click one more time. You can see that you can use the build pack, which is what we saw before. So uploading any kind of code, but you can also push a Docker image. So if you have already an image like that and you want to run it, then fine. Then this also works here. However, you don't get the other benefits as I described in a few seconds. So the first step is uploading your project folder if you choose this build pack path. And then basically this can also be done at any time with the create package command, because this uploaded code is called package in Cloud Foundry terms. And here, once again, you can also choose a different path, or if you previously chose to host a Docker app, here you can specify the registry host and port and image, and optionally also a tag that you want like to upload. So you don't, after that, need a registry or something like that, a container registry. Then after that, the packages live in Cloud Foundry. So, and after you got your package, you can also list them and always go back to a previous package version if needed. But after that, the build process starts. So basically, from these packages, the container base images are created, and the work in Cloud Foundry is done by the build packs. And here I listed some build packs that are normally included in such a distribution. So what we already saw was the static file build pack, which is basically spinning up an Nginx and just serving the files statically. But you can also alter the Nginx configuration to include authentication or custom headers or other stuff. And besides that, there are a bunch of languages that are supported, like Java, Ruby, .NET Core, Node.js, Golang, Python, PHP. The binary build pack, which is also interesting because you can just upload any binary that runs on Ubuntu Linux, and it will just also run as your web process. And if this is not enough, you can always specify with the -b flag in the CF push command an arbitrary GitHub URL that will host your build pack, and then Cloud Foundry will use that build pack instead. And I also will show you shortly how this looks like and how you can build a build pack. And afterwards, you can even stack build packs. So I also had once an app, a .NET app that made the end users also to run JavaScript code, so you can also combine Node.js with .NET and so on. However, the last build pack wins, so to speak, and is the main web process, let's say. But when this container image is built, and this is also something you can redo anytime with the stage package command. This will always trigger the staging process to use the code with help of the build pack to build a base image. Then in the end, you get your base image, and in Cloud Foundry, this is called droplet. And you can list all these droplets. So when, for example, something goes wrong and you also lose connection to your repository or whatever, you can always go back to a previous droplet and set this active because, yeah, so for example, as a fallback, most developers never need these kind of commands, but I think it's good to know that these are included. And when you have your base image, everything is staged and available, then you just need, of course, some kind of DNS name or route to your application. In Cloud Foundry, these names and that you can map to an app are called routes. And a route consists of a domain name. Mostly you have a shared domain like apps.yourcloudprovider.com and then your app name in front of it. But in Cloud Foundry, a route also can optionally consist of the path afterwards. So you could have like here, have your example app and /foo points to a different app, but for the end customer, it just looks like one app. So this is maybe also good to know. But DNS name and optionally a path altogether is the route. And of course, you can also use your own domain names if you don't like the names from your service provider. Then you just create your own and map it to your app. And then the final last step is then to start the app. This can also be done with the cf start command, with cf stop or restart. You can stop and restart your app. And this is what is called the so-called cf push experience, because in Cloud Foundry, the developer is in the center and everything is built around the developer to be as productive as possible. But what happens if you now face this vulnerability, let's say in the Java build pack or in the Java runtime? Then, as you could see before, the Java runtime is included in the Java build pack. So this is quite easy for a developer. As soon as your platform operators have patched the build pack, you just say cf restage your app name, and then the app takes the last package that has been uploaded, and the updated build pack, and altogether builds the new droplet, the new base image, and starts it. And if you choose the rolling update strategy, then this will also come without any kind of downtime. So basically, you have blue-green deployment built in. However, if you would like to do manually the blue-green deployment process, you can also do this with the map route command that we saw earlier already. So you could map this the same route to a different app, let's say to your new version of your app, and then the load balancer will automatically round robin distribute the load among all available containers. And if you're happy with the result, then you can unmap the route from your old app container, and then all the traffic just goes to the new app container or containers if you have multiple. And if you're not happy, you can just unmap it from the new one. So this is how you can do a blue-green deployment manually. Or if you like to, you can also use this for A/B testing or any other stuff. So, or just distributing the load among different versions to try features and other things. So there are different ways. So it's an N-M relationship between routes and apps. Right, and if you have not enough resources, we already saw it in the small demo, but just to recap, you can also scale your app, and if you say -i50, then you get as many containers as you can see on the screen. But there's also some auto-scaling services that you can use. So you would most likely just define some policies like if CPU goes over 80%, then scale up, or if requests per seconds is more than this amount, then I know my app is not handling it well, and I should maybe scale out. And if you look at the scale command, you see that there is something like a process. So basically, what is the process then? We just talked about web apps and to push them, and what does it mean? So basically, you can, of course, have multiple processes within your application. So this might make sense, for example, if your app contains a web process that handles all the web requests and a worker process that does some stuff in the background. And if you would like to scale these two processes differently, then you can do so. And actually, you can call these processes as you wish. So type is not like web and worker and that's it. It's an arbitrary string that you can choose. And then you just need to specify the command and the amount of instances that you like to have. You can even give these instances different amount of RAM and disk space. But this is then an example where you have to handle some YAML. But as you can see, it's just a few lines, and then you can push it the same way using this manifest file. But there is also something else. There's also the tasks. So processes are there for long-running processes that need to be monitored and restarted if they crash, right? Because you want your app, your web process to run constantly, and if something goes wrong, the platform should restart it and work with and keep the show running. But maybe sometimes you have commands that you would like to run just once. For example, a database migration script or some backup tasks or something else, anything you would like to run one-off. Then you can use the run task command, and you can specify the command to be run, or you can specify one of the defined processes that you would like to run. You have different ways, but the good part is it uses the same container, the same base image, and you can also specify the resources it will consume differently, separately. But then there's even more. Maybe you have heard of sidecars. For those who haven't, very short introduction. So sidecar is a process that lives inside your app container. So here I brought an example from our partners who have a nice documentation about a Telegraph sidecar that runs inside your app container, and that scrapes the metrics from this app and then pushes all these to Prometheus, so that you later on can have some nice charts and diagrams and all the stuff. And basically, sidecar is then always running besides your app in the same app container. So if you have 3 instances of your app, so meaning 3 containers, then you have also 3 sidecars in each container 1, and so that makes it different from processes and tasks. So to summarize, we now saw how this platform generates container images from source, how the source code is uploaded into a package, and with help of build packs, a droplet is created, which is then the base image of your app containers. And these are called instances in Cloud Foundry, and then they can have one process, or additionally also some sidecars, or you just have a task in your container to run one time. However, the processes are monitored. You can also define how they are monitored. If they are just, the platform should check if the process is still running, or if a port is open, or if you have a health and point that should always get a nice 200 return code, then you can also use that. You can have different processes, web and workers, and whatever you like with the same base image, and this would all belong to one app in the Cloud Foundry context. And now, if time allows, and I think it does, we can jump a bit more into the build pack topic, and I can show you briefly how this works, because I know from the outside this all might sound like I don't know, a different world, and it is, because Cloud Foundry is older than Docker and Kubernetes, so they have their own terms, and this might be a bit strange in the beginning, but basically it's not magic. It's handling the similar concepts, just maybe taking a bit ops work away from the developers, but in the end, it's pretty similar. So here I brought a build pack which allows you to just push some data and afterwards create an API that uses that data to predict values. So why am I showing this? I'm showing this because in this example, you just have again an empty directory. I mean, you can try this out by cloning this AI project and then going into the directory and do a CF push. So it's that easy as that, but I will now show what will happen if you clone this project. Basically, this project is just an empty folder with one file, and this is the AI JSON file. And this file includes this data here. So just some JSON with some inputs and some target values, and that's it. And if you push this with the AI build pack, then this AI build pack will check this file, look at the data, train a model with this data, spin up an API that allows you to do some predictions. And this is how it works. So in the end, you have your app at, for example, ai.example.com. With /model, you just see the model, and with the posting some new inputs, it will predict some new target values. So basically, with the help of a build pack, you cannot just only push source code, you can push whatever you like, if your build pack is knowing what to do with it. So, and what do you have to do to create a build pack? A very, very simple standalone build pack just has 3 files: compile, detect, and release. And these are just scripts that need to run in a Ubuntu container. It's because these staging containers are built upon a Ubuntu base image. And then if you use the compile script, this is actually doing all the magic. So you have, you get from the outside a few directories with the source code that the user pushes, and then also a cache directory. And then you can start copying files around and doing whatever is needed with help of your build pack to do, to work with the files that you get from the end user. And then with these 2 other scripts, with the release script, you specify the run command. In this case, you see I use just Python with the server script that spins up the API and consumes the AI JSON script or a data file. So very simple command. That's basically it. And the third script, the detect script, is just an optional script that you can use. I don't know if you remember, but when I initially pushed the first very simple app, I didn't specify any build pack. So basically, the platform looked at all available build packs and chose the right build pack. And this detect script enables this magic, because here you can see I just try to find an AI JSON. And if I find this, then I say, yes, I'm the one, I'm the AI build pack, and I can handle these kind of files. And otherwise, I just exit with the code 1, indicating the platform that I'm not the right build pack. The same, the Java build pack works. Whenever you see some Java related files, it will say, here, I'm the right build pack. And similar with the other build packs. That's basically it. I also included the build pack documentation here, because then you find out that you can stack build packs and how to work with that. It's also very easy, because then you would just, instead of a compile script, you will provide either a supply or a finalize script. So basically it's doing the same, but the finalize script is taking into account if your build pack is the last one, to finalize the build process and to define the web process and everything, how to start your app. And the supply scripts are basically just providing additional stuff on top in this build chain. And I also have an example for that. Therefore, I created the Jupyter Notebook build pack, which basically builds upon the Python build pack and is designed to run before the Python build pack as a supplying build pack, just to inject the prerequisites that you need to run Jupyter Notebook files. So let's see how this looks like. So if you use the Jupyter Notebook build pack, you can go into your directory that is hosting all these Jupyter Notebook files. And then you just say push my app with this Jupyter Notebook build pack and with the Python build pack. Then you define some memory and disk constraints, and that's basically it. And if you want to log into it, because these basic Jupyter Notebook project is normally secured with a token, then there is also a command how you can SSH into your notebook app to get this token out of the right file from your container or your running app. And how is this working? As you can see, the Jupyter Notebook build pack is very, very slick. So it's just including a license file and this supply script. And basically it just puts some additional requirements in your requirements.txt file. As you can see, it's added. So if you have already a requirements.txt file in your folder because your Jupyter Notebook files need some Python libraries, then it just adds the Jupyter Lab and other dependencies, defines the web process, and that's a runtime. Because I figured out that with the dependencies that I chose, I had to pin the Python version for now. But you can also adjust this as needed. And then it just in the end writes a done message, and that's basically it. So, and to test this, I also prepared a project which includes some example Jupyter Notebook files and also a manifest that includes this reference to the right build pack, and you can directly clone this repository and push it. And I think we have 3 minutes left, so let's directly try it out. Because in the end, I would say, because I have one last slide, I want to like to show you first. So if you are no Cloud Foundry fan yet after this presentation, I can totally understand it, because everyone is having a different background. But if you still like the concept of build packs that I showed, you can have a look at least at the Paketo.io project, because this project is doing the same build process. So you can just start with your source code and with the build packs, and then in the end you just get a basic Docker container or whatever you like, and then you can use this in your Kubernetes clusters or whatever. If you are more familiar with that, or if you want more control, of course, because Cloud Foundry is more cloud native app platform. So if your app is not fulfilling the 12 factors and, for example, has state in the app or needs local disk space or things like that, then Cloud Foundry is not the right platform and you have to choose something else anyways. So yeah, that's basically a nice alternative if you want to stick to your other platform. And then in the end, I just can say have fun and let's maybe give it a try to push this Jupyter Notebook, because I think this is also an impressive presentation of how you can use build packs. So I just go into the fun CF repo and to the Jupyter Notebook project, copy this, and go back to my console. Let's see. Is that it? It's not the right window, is it? Never mind. I can use this compiler. Anyways. So I clone this directory, I go into the directory and I directly push it. So let's see. At least the upload worked. Now I'm staging the app. In the end, I see setting up Jupyter Notebook dApps to work with the native Python build pack and the done message that we saw on the screen earlier. And now the Python build pack comes into play, because as you can, you cannot see it here, but I can, while it's loading, I can show it in this repo. No, sorry, no, now my window is hiding. Come on. There we go. Sorry. So here I have this manifest file. So basically it just sets the memory and disk quota and defines to use the Jupyter Notebook build pack from the FunCF repo and then the built-in Python build pack. So that's basically it. And if I go back, I also should go to the build pack to get the SSH command to get the token. So now the droplet is already created and it's uploaded. So once again, no registry or other components needed. And now the instances are starting. Which also takes a bit longer than starting just a simple Nginx. There we go. So now I retrieve my token and I just grab the new URL. So my web browser. So here you can see the Jupyter Notebook login screen, and I just need this one-time token to log in, and then you can see all the files that I uploaded. And to compare it, if now I I list the files in my directory, you will notice that these are exactly these files, and you can just start Jupyter Notebook, meaning play around with Python in a web browser. That's it. All right. Thanks so much for listening until here. And now I think we have a few minutes left for questions. So just go ahead.
Maurice, hello again.
Hi.
Thank you so much for the talk. And yeah, as you already mentioned, we got some minutes left. So I would say let's jump into a quick Q&A if you're ready for it.
Sure.
All right. You definitely filled some roles in your past, in your professional career. So maybe also to you the question how you became interested in tech at first and how you ended up in this position where you are now.
In tech in general, you mean?
Yes, yes.
Okay, so that for me that was easy because I was always into tech. With the age of 14, I started programming on a friend's Commodore. And I also always liked to read programming books, even though I didn't maybe have the hardware for using it. So that was very early, and then it just during school I focused on these technical subjects and topics, and directly jumped into a studies with cooperative education, so where you learn training on the job and you study at the same time. And I always would recommend this path because it's not only theory, you can always directly try it out and learn what is required to you from a company and how to work in a corporate environment.
But thank you for answering that. And yeah, let's jump to some of the technical questions from the attendees. The first one would be, what sets Cloud Foundry apart as a true APaaS instead of just another container infrastructure as a service solution, in your view?
Yeah, so I hope that I could explain it with this one picture, but it seems that I failed, but I can retry, because if you look at this picture, I hope I can jump back to this. Yeah.
Yes,
So
let's bring it up.
Then a true application path in my eyes is a platform that allows you to just push your application and to handle your data. Whereas if you use a container infrastructure as a service solution, you have to deal with the runtimes and the middlewares and the operating system based, to some degree at least. And you as a DevOps have to patch it if it's broken, and or if there's a vulnerability. So that's, I think, the main difference. And also, if you look at speed, so before the session, I actually plan to have also a similar demo with Kubernetes, but I failed. So it's also a matter of experience. But I believe really, if you're new to Cloud Foundry, you can start very fast and without a deep learning curve. That's the main difference, I think. And it's not just about Cloud Foundry. If you use Azure Web Apps, it will be the same, right? You just push your code and run the app, and you don't have to deal with building a container and hosting it on a registry in a secure way, and then reference all this stuff and dealing with credentials and all this. Yeah.
But thanks for clarifying that again. And let's jump to the next question. How does Cloud Foundry prioritize or handle security issues or concerns during the development of cloud-native applications?
So basically, during the deployment of cloud native applications, so basically, it's a shared responsibility platform, right? So Cloud Foundry itself do not prioritize anything in your cloud native application development process. However, all these components that are used, of course, the open source community is eager to support the latest base images of its own Ubuntu hardened base container image, and also of all the other components among it. So I'm not sure how else to read this question. And all the rest, the remaining, how the build packs and all the stuff is updated. It also a bit depends on your cloud provider. If the cloud provider is acting fast. For example, this log4j issue, there were some intermediate steps you could do to mitigate it a little bit. For example, by setting some environment variables, then your cloud provider can do this directly and force it for all applications. So you just have to restart your application, and then it already gets from the cloud provider additional environment variables to mitigate it already a bit until all the runtimes, build packs, and all the other images are fixed, and you are completely safe. So I would say this is also a prioritization to check what you can do very fast, and then step by step mitigate all the risks.
Right. Thanks for that answer, Maurice. Let's jump right to the next questions. Can skills acquired from Kubernetes experience be easily applied to Cloud Foundry?
Easily applied, I'm not sure. So there are some similar principles, so for example, building apps that can be restarted at any time, or building apps that scale horizontally easily. So these skills and basic concepts help you in any way. However, other than that, how you configure the deployments and the YAML on this one side of Cloud Foundry and the YAML of Kubernetes is completely different. So there are some different concepts. But the other way around, if you like to work with build packs, you can use, look at this Paketo build pack thing that I showed to see if you would like to do this also in your cloud, in your Kubernetes environments. But there's also something, Cloud Foundry was designed to run on VMs in the beginning, and it used its own intermediate layer called BOSH, B-O-S-H, to orchestrate all the VMs and all the processes on the VMs actually. However, there is a project, an interesting project called Corifi, which is exchanging all of that and running on top of Kubernetes. So in this case, you really can reuse all your skills from Kubernetes, because the Corifi project will use all the Kubernetes components as it makes sense and as available to run the Cloud Foundry apps directly as pods on Kubernetes. So maybe that's an interesting second project to look into, because then you have the same look and feel, same API, same CF push experience, but in the end, it's just all pods running on your Kubernetes.
Right. Thanks for sharing insights on this as well. And we got another question. What are the downsides of Cloud Foundry? Are there any limitations?
Yeah, there are limitations. So first off, what I showed is a shared platform. So you are sharing the resources with all the other customers. If you have every resource hungry applications, you might like to have your own clusters, right, of your own worker nodes, and maybe specific types of worker nodes maybe with GPUs and things like that, then I recommend to use directly a Kubernetes service that allows you to adjust for that and to configure all of that. So that's basically a limitation. And the other one is 12-factor apps. There is no persistent storage unless you include, object storage or other mounting something from a public other service. So that are two limitations I can think of.
All right, and we got 1 minute left for one quick question, maybe. Are there specific SEC features or strategies developers should pay attention to in Cloud Foundry?
Specific security features or strategies? I don't know any specific that you should pay attention to. I mean, you should always be aware of security and where to get your sources from. So maybe, if you push your app with a public build pack using this GitHub URL, you should probably check the resources before you do so, and also always pay attention to what other third-party libraries you include, because the build process is then hidden in the background, and if you use public URLs and mix it, then you should pay attention to that.
Of course you should. Maurice, thank you so much for the talk, also for the very valuable tips you gave now during the Q&A, and hope you have a nice rest of the day and see you soon.
Thank you for having me, and I wish you the same. Thanks for the questions. Great audience.
Thanks, Maurice. Bye.
Bye-bye.
All right, and before we jump to the next speaker of the day, just a 10-second break. And right back to DevOps and the next speaker of the day. He's software engineer and DevOps lead at OwnID, and he's a certified AWS solutions architect, and with his 12 years of experience in the field, he certainly knows what he's talking about. Welcome, Yedidia.
Hey, what's up?
Hey, what's up?
How are you?
I'm
really happy to be here. Great.
But happy to hear that. So you're very enthusiastic, but before we start with the talk, it would be awesome if you would share just real quick with the audience and me what we are going to learn from you today.
Yeah, so today I'm going to actually cover our architecture refactor that we had at our company, and actually how we took our passwordless authentication product performance to the next level. I'm going to cover a lot of things, the challenge that we had, the problem, which tools we used in order to achieve what we wanted to do, the requirements list of the things that we wanted to have before starting the process, and all the difficulties that we have, and what worked for us, what didn't work for us, and what is the must-have things that you need to do to achieve what you want to do at the end. Like, I'm going to give you a few really good takeaways from the process. We are going to talk about passwordless authentication, because this is our core technology. A lot of topics, really.
Okay, so many experiences you made, which the audience can gain from. All right, you did that. Then I would say, without steal any more of your time, the stage is all yours.
Thank you. So, as I said, I already mentioned what we are going to cover today. I want to say a few words about myself, although you already presented me, and it was really nice. So I'm actually at OwnID. I'm leading the infrastructure domain. I'm designing and implementing all the design reviews that we have, the complex features that we are developing. I'm dealing with observability, monitoring performance, and all these things. But before my current role, I was a tech lead at WalkMe, and I was a commander at the IDF. I'm a certified AWS solution architect, and I'm holding philosophy BA and MA degrees, not a computer science degree. Before we will start, I want to tell you what should you expect from this session. So we will start with the passwordless technology overview and how our solution works in general. Then I'm going to present the problem that we had. We're going to dive into a real case study, and we will see how our current architecture is implemented and what are the changes that we apply on it. And then I will give you the takeaways. So to give you the context of the technical aspect of this session, I want to cover shortly the product and where he meets our customers. So we are a web-based authentication solution, and we are actually increasing the identified users in websites. We are using passwordless solution with FIDO, 2 WebAuthn API passkeys, and many more technologies. I want to cover now a few of them to give you the context of what I'm going to talk about. So first, we have the FIDO. FIDO 2, that's actually the newest set of specifications from the FIDO 2 Alliance. It enables the use of common devices to authenticate to online services on both mobile and desktop environments. It's actually using a unique cryptographic login credentials for every site. Essentially, FIDO 2 is a passwordless authentication, okay? Then we have WebAuthn. This is also a very common term that you may hear regarding passwordless. So FIDO 2 and WebAuthn are not interchangeable terms. The WebAuthn is the main component of FIDO 2, okay? The set of standards and APIs allows the browser to communicate with the operating system and deal with using cryptographic keys. WebAuthn falls under FIDO 2 standards, but it was developed by the W3C. And the last term that I want to cover right now is passkeys. Probably you heard about it. This is actually an implementation of the FIDO 2 standard, in which in this implementation, specifically the FIDO 2 credential may exist on multiple devices, such as on your phone, tablet, or laptop, and across multiple operating system platforms. Apple, they popularized this term passkey in recent months with the release of iOS 16 and the macOS Ventura. Apple's passkeys implementation, they use biometric authentication such as Touch ID and Face ID to sign into websites and apps. So the term passkey was first coined by the FIDO Alliance, but is now being used by a lot of companies, including Apple, Google, and Microsoft. Passkeys are seen as promising alternative to passwords, and they are likely to become more widely used in the future. And you can visit passkeys.com for more information about passkeys. This is the high level of our architecture. I want to show you everything before the change that we did, so you will get the main idea of how things work. So we have an end user that opens one of our customers' websites on mobile or desktop, and then he meets our product as part of the login form, because our product integrates with the login form, and that's how it looks like. You can see it's the small widget. Okay, this is a screenshot of our login forms of one of our customers, and you can see the widget. If you click on it, it actually triggers the unlock mechanism of the device. On desktop, it can trigger the passkeys, and if there is no biometric supported, it can show you a QR code to scan with mobile. Then our server performs the authentication process. It uses a challenge that is sent from the end user device. It's based on a private key. That private key never leaves the device. And then we are holding on our server the private key, this challenge. Then our server gets from the database, from the user base of the customer, the public key of the unique cryptographic login credentials for the specific end user. And the public key is stored in the customer user base. As I said, it can be an in-house solution of the customer or a third-party product. As you can see, Okta, Auth0, Firebase. we, as OwnID, we are not storing any data on our side. We are just authentication mechanism. We have out-of-the-box integration with the most common identity providers and the programming languages. So this is where the technologies that I mentioned before come into action in the architecture. First, on the browser, WebAuthn API allows us to trigger the unlock mechanism of the device. Then the passkey, private key, is stored on the device. It never leaves it, as I said, and the passkey's public key is stored in the database. On our server, we are using a FIDO2.NET library. With that library, we actually validate the authentication using the public key and the challenge, which is based on the private key. And aside to our product, the regular authentication mechanism of the customer can still work as usual with passwords, but there are a few customers that decided to completely remove that option and go completely passwordless. So let's now talk about the problem. That's how our widget looks like. As I already showed you, the widget must look native, okay? That's what we understood. It must look as it is a part of the website. It can't be loaded with any kind of delay. And the issue was that we experienced many, many delays around this issue. From time to time, the widget was loaded with a delay, and sometimes it wasn't loaded at all. Okay, it didn't look good. It was blinking. Look, it was like that for 2 seconds, and then it suddenly appeared. So this, we can't afford ourselves to that this will be our face in front of our customers. So our product is accelerating the authentication process using passwordless, but the performance of what happens before and after to the core process of our business is also a part of the end user experience. This is actually a part of the time that it takes to the user to be logged in because he's waiting for our widget to appear. And if we want to accelerate the full experience, we must be the best on that part of the flow too. We are serving many huge brands, so we need to be in their standards. It's required very, very high level, top level performance because they have a huge scale, all this list of customers and many more. And we are a multi-tenant based company. So we have few servers that need to serve all the customers at once. And on peak time, when many, many end users log in for all the customers, we need to support a huge scale, like 10,000s of impressions of our product in a second, okay? So now once the point we want to improve is clear, let's dive in. That's what we had at the end of 2022. These are some of the requests that had to be sent from the browser in order to load the widget. First, we have the Web SDK. This is an SDK that we load for a specific provider integration. On this case, you can see that it's Firebase. It's an integration for a customer that works with Firebase. Then we are loading also translation files and the dynamic request to get some configurations for the specific tenant of the customer, for example, the widget color and things like that. And all the requests are made to a CloudFront distribution, as you can see in the diagram. And the CloudFront distribution, the CDN, is referencing S3 buckets for static files or a load balancer for dynamic requests. So this solution has a very high latency from time to time. Request dependencies it has because there are requests that needs to happen one by one. And we decided that we don't want a short-term solution as a plaster for it, but a bombastic solution. We wanted top-level performance, so we wanted a solution that will stay with us for a long term while we are growing as a company. So after I show you the situation that we were at, now I want to move to a very short theoretical part of 2 design patterns that I want to talk about. The first one is materialized view pattern. So in computing, a materialized view is a database object that contains the results of a query. If we will think about restaurants, it can make it easy to understand. For example, in McDonald's, the orders are provisioned in advance. It's a complicated query that contains meat, tomato, sauce, bread, fries, that are all waiting for you in a box to order them. That's a good McDonald's branch works. You can wait only 1 minute to get your food because everything is ready in advance. So that's exactly how the materialized view pattern works. It is being used, for example, to store the results of a complex join query, a result of a query with a huge amount of data, or a query from multiple slow data sources. And Twitter X, for example, they are using this approach to hold your feed ready in advance. So when you open the app, you will get it very fast because they already baked it behind the scenes for you. And the second design pattern that I want to show you is the server-side composition. Let's assume you have 3 different front-end components and the browser performs 3 requests to load each one of them. The design pattern brings the idea of performing 1 request to load all of them at once. So you need to add a proxy server that merges the components into one file, a JS file, HTML file, and then it returns it to the browser. There are many out-of-the-box solutions for this proxy, such as Podium, and also Nginx module has a nice solution. There are many more. Okay, so now that we know all the theoretical parts, let's convert everything to something practical. So we have a requirement checklist of 5 bullets. That's a well-defined list of technical requirements that we agreed about before starting the architecture planning, okay? The first requirement that we need from the solution is to have very fast queries of our resources, because we need the dynamic configuration, the static files, we need everything to be queried very, very fast. We want to merge all requests into one to reduce the failure rate. If everything is merged into one request, then you have less network requests, less chances for a corrupted load, or even that it won't load at all, won't be loaded at all. And then the widget needs to load together with the website, as I already said, as close as can be to 0 milliseconds. It should look native and not like a third-party service. And the mechanism should support a huge request scale, tens of thousands in a second on peak times, and the response from the server must always be as updated as possible. Let's say that if one of our customers decide to change the widget color from red to green, so we want that it not more than 1 or 2 minutes, all the end users will see a green widget. So I already showed you that's how the widget loading architecture used to look like before the process. This is the first step of the new architecture. We are preparing all the resources, dynamic and statics, under the same data source. Config server reads the data from the various origins and write it to Redis in a specific predefined structure. In the next step, I'm going to show you the component that reads the data from Redis. So this step solves the first requirement. From now on, reading the resources will be super fast. It exists on Redis instead of S3 buckets or database. You can just read it very fast. As I said, the next step is reading the resources from Redis. That's the responsibility of the baking server. This is actually kind of the core of the solution. The single concern of this microservice is to get an app ID, which means an ID of a tenant of a customer's website, and then return a JS file with all the relevant resources and data and configurations and everything in just one file. Translations, the SDK itself, everything. And the logic in high level is split into 3 parts. First, we create a template of the output with placeholders instead of the actual resource. Then we read all the relevant values from Redis. Then we just replace the placeholders with the data from Redis. That's an example of an output of such a file. You can see that it actually brings you in one request everything. So this was the baking server. It covers the second requirement of merging the request into one. Now, the baking server is becoming the bottleneck of our architecture. On peak time, as I said, there may be tens of thousands of parallel requests. We have a Kubernetes cluster. It has its limitations. And once it will get a huge heat of requests, probably few requests will be denied. So the solution for this is introducing a CDN between the browser and the baking server, CloudFront CDN. I want to give you a short brief of CloudFront CDN in the way that it solves our performance challenge. I will emphasize some critical capabilities that change the picture of the architecture, actually. So a CDN is a content delivery network. It is known mostly for performance boosting of static files loading. Instead of one main server, it gives you a distributed servers network. If you are from Israel, you will get your data from Tel Aviv. If you are from Brazil, you will get it from Sao Paulo, for example. Every local server is called an edge location, and the main server is called the origin. The edge location can store everything, and the origin can be many services like S3 buckets, a server, or anything else. So the first request to an edge location to get a file will trigger the fallback. So the request will move forward to the origin server. And on the second request, the file will already exist on the edge location. So the origin server won't even be aware that the request was made. So instead of getting the widget from the baking server, the CDN will handle most of the requests, theoretically one request per edge location. So AWS has more than 400 edge locations, so baking server should be capable to deal with it. Now I want to challenge this solution. Let's say that one of our customers send a marketing email to its 20 million registered end users, and in the marketing email, it says the first 100 people to log in and fill the form will win $10,000 each. So let's say that the relevant file of the widget of this customer does not exist on the edge locations in that moment. It was invalidated or something. I will talk about invalidation later. At the same time, tons of end users will load the widget. They will want to log in to take the money. All the requests will reach the CDN, and the CDN won't have the required file on the edge location. Then baking server will get tons of parallel requests in a huge peak and won't be fast enough to scale. And end users will just receive 500 status. They won't see the widget. They won't be able to log in. They won't get the money. It's not good. Exactly for that, CloudFront has a built-in feature, request collapsing. Let me explain about it. When a CloudFront edge location receives a request for an object and the object doesn't exist, so CloudFront immediately sends the request to the origin. However, if there are simultaneous requests for the same object, which means that the additional requests for the same object arrive at the edge location before CloudFront receives the response to the first request, CloudFront knows to pause before forwarding the additional request to the origin. This brief pause actually helps to reduce the load on the origin. CloudFront sends the response from the original request to all the requests that it received while it was paused. This is called request collapsing. So to make sure that the CDN behaves as we expected, once we went live on production, we took one customer. We rolled out gradually the solution. So we took that one customer that had the solution, then we opened CloudFront reports page on AWS console. For each file, you can get statistics, okay? So how many requests were performed, how many of them hit the cache successfully, and how many of them missed, which means the requested file didn't exist in the edge location and the request fall back to the origin. So in a week, I found 253 misses, as you can see, which means that 253 requests that reached the baking server. That it makes sense, this number. Then I wanted to double check it because I can be sure that actually I don't want to rely only on one source of truth. So I went to a monitoring tool. It's a Datadog. And the APM, the Application Performance Monitoring product, counts every request to our server. So I filtered the request to the specific file. I found 249 requests. The numbers are closed, so as I expected. So it looks okay, makes sense. So that's actually was kind of an approval that the solution works as I expected. So at first we thought that we made it and our bombastic solution can suffer every load, but then we started to roll out the solution to more and more customers, okay? And then a few months later, we started, of course, to notice errors coming from Redis. An error means that the end user doesn't see our widget at all. He's probably the first end user in his area, near to the CloudFront edge location, that requests the widget after the invalidation, after it was removed from the edge location. After a long investigation, we found out that we crossed AWS Redis network allowance limitation. This is a specific graph that you need to search into it inside your Redis dashboard in AWS, but it's an interesting one. I heard about many companies that had the same issue. We had actually the hotkey problem. Too many Redis requests that were sent to the same shard, okay? To tackle the issue, we had to reduce the requests that are performed to that specific Redis shard. So we tackled the issue in 3 ways. First, we sharded out the key that caused the issue. It means that we created 100 occurrences of the same key with different names, with different prefixes in random shards. I won't elaborate about the solution right now because we don't have the time. You can go and read about it. Secondly, we added an in-memory cache above Redis, okay? In the baking server, everything is also cached in memory. And finally, we also leverage an extra CloudFront feature that exists exactly for such cases. This extra feature is Origin Shield. So this is the regular architecture of CloudFront without the Origin Shield. And it looks like this. Behind the edge location, there are extra caches, actually. There is a regional cache to decrease the request to the origin itself. But this architecture wasn't enough for us, because although we had regional edge cases, on the peak time, we still had too many requests to the origin. So Origin Shield is when viewers are in different geographical regions, requests can be routed through different regional edge cases, and each of which can send a request to your origin for the same content. But with your Origin Shield, you get an additional layer of caching between the original edge cache and your origin. So all requests from the regional edge cache go through the Origin Shield. It's actually reduce the load on our origin, on the baking server, and this may be very helpful if you suffer from issues like we had of too many requests. So as I said, we added also the in-memory cache in baking server. That's a screenshot of the APM traces from Datadog while testing the baking server in-memory cache on a specific file, okay? The first request, you can see the one at the bottom. It went to the database to retrieve the data since it wasn't existing even on Redis. The database is the worst fallback that we have. It's actually, we are using the config server to read the data again. Second request took the data from Redis because then we stored it on Redis. And then the third and fourth request took the data from the in-memory cache. So I want to summarize the protection layers that we have to load the file. First, we have the CDN edge location. Then we have the request collapsing mechanism. Then the regional edge cache. Then Origin Shield. In-memory cache on the baking server. The Redis cache. And then, if all these 6 protections didn't help, then the data is fetched inside Redis from the database by another microservice. So CloudFront supports like 250,000 requests per second, according to the documentation. So looks like we are okay for now. Fine. So scale requirement checked. Now, the last requirement was keeping data updated all the time. If the customer updated the configuration, changed the style of the widget, or changed some fallback OTP email to SMS or something like that. So all the end users should be affected in not more than 1 or 2 minutes, okay? So to achieve this, we leveraged a mechanism that already existed in our architecture, Redis PubSub. This is actually a messaging mechanism over Redis using publishers and subscribers. So the cases for updating the widget can be split into 2. First, we have the individual update, only for one customer, when he updates his own configurations. And the second type is a global update, when we change something that needs to be applied on all our customers. For example, translations or the SDK file on deployment of one of those. So then you need to actually update all the files for all the customers. So these are actually our publishers. And each one of these processes can trigger a publish. Once one of these events happens, it's publishing a message to the relevant Redis channel. Config server is the subscriber. Once it gets notified that it needs to update the data, it rehydrates the data from the source of truth, from the database or the S3 buckets. It reads, and it then writes it into Redis. So now Redis has the fresh updated data. On the next step, config server triggers a CDN invalidation using AWS SDK programmatically. The old cached data is removed from all the edge location. This is the invalidation process. When you trigger invalidation to a CDN, you remove everything. You can trigger for individual file, we can trigger the specific path of the file, and for global, we can actually invalidate everything. The first end user from each edge location will reach to the fallback, to the baking server, and he will get the new data. From this point, the new data exists on the edge locations. So that is actually the last requirement that we had to achieve. Now the data stays updated. After all the process was finished, this is how it looks. I refreshed the same website 4 times. For the first time, there was a fallback to the baking server. And after that, the file was fetched from the CDN. So if you remember at the start of the process, it took like half second to load everything. Now we are in 14 milliseconds. So it's 100% of improvement. It's a huge process that we had. So as I said, the legacy loading approach was still functioning when we moved to the new mechanism. The solution was gradually rolled out. That actually allowed us to find performance issues and tackle them before they affected all our customers, because we did it very, very slow. And the design patterns we talked about, they come into action on these parts of the architecture. You can argue about that, since every design pattern can be expressed in many aspects. That's how I see it. We are materializing the possible combinations of data in Redis for every customer, and we are compositioning the components using the baking server and the CDN. A few takeaways that I would like you to remember. First, the proposed solution was designed in light of the existing architecture that we had. We leveraged config server, Redis PubSub, and many more components that we already used. So I recommend you that if you can, once you need to have some architecture refactoring or a new big feature on the infrastructure aspect, you should avoid from new components to maintain, because you don't want to add more background noise to something that is anyways complicated. Second point is that you don't need to be afraid to change key decisions of your architecture during the development process. It's better to change things early than stay with the problems for years later. For example, we talked about storing all the baked files on S3 buckets and then we totally changed the solution once we realized that the global invalidation will be a very slow process, and we didn't want to have such a process. So we totally changed the solution after we started actually to work on it. Then observability. You don't start to move if you don't have the proper monitoring and observability tools. I can't even imagine how many production issues we would have without the powerful monitoring tools that we use, like the Datadog and the dashboards that we have inside AWS console, and many more metrics that we are collecting. Regarding design patterns, it was very helpful to think about the design patterns that I talked about before. The implementation is very flexible. The design patterns needs to serve us. That's what you need to remember. We shouldn't serve them. You don't need to be design pattern oriented. You need to see how they can open your mind, and then you need to utilize them in your style. Because sometimes I see people that take a design pattern, read how it should work, and then just trying to change the architecture to match the design pattern. But you need to think the otherwise. So boosting the main process that uses the core technology of our business sometimes depends on process that come before or after. The user experience is an overall experience. You need to remember that. Even if the passwordless experience itself is amazing, it really worked amazing before, but if it's not loaded on time, or it's not loaded at all, so it's not good enough. So you need to think about everything, not to stay only on the core business once you think about performance. So that's kind of what I wanted to cover today. I hope you learned something new and that I opened your mind in some way. You can read more deeply about the process in the article series that is published in our engineering blog. A few months ago, I published it. And thank you very much.
Yedidia, hello again. Thank you so much for the talk.
Sure.
was really a blast. And yeah, we got some time left. So I would say let's jump into a quick Q&A, if that's fine with you.
Yeah, sure.
Perfect. I read in your bio that you have 12 years of experience in the field. And so I was wondering, how did you start out in the tech field? How did you become interested in it? And where did you get from there?
Yeah, actually, I am from Israel. And on 18 years old, I started to serve at the IDF. So actually, I learned all the basics in a course on the IDF. And then I was like 7-8 years in several units in the IDF. We developed very interesting systems. That was like the first actually hands-on work that I had in my career. And after that, and actually I had many roles during the way. I was a team lead, then I was a tech lead, and only in the last year and a half, I became a DevOps, okay? I'm not a dev. I wasn't born as a DevOps. I was a full stack developer, a backend developer. And then I really like fronted a few years ago. Now I'm a dev. So you can't know what the future brings.
That's awesome. Very interesting evolution there. And it shows also how many positions are there in tech or in the broader area of tech. Awesome. Yeah. Thanks for sharing this with us. And let's tackle some of the more technical questions then, I would say. The first one would be, how do we take care the security of the CI/CD? Is it possible to pen test the system? Care of.
So about the security of the CI/CD, I'm trying to think about this question in light of the architecture process that I showed you. So we have a very secure CI/CD, like we are storing all the secrets, some of them in GitHub Actions secrets, and some of them in Kubernetes secrets. So, and we also have penetration testing. Like people try to test us, absolutely, and nobody found something serious. But I guess that every system has its vulnerabilities. You just need to be aware of it and be prepared for it, and try to think about things that may happen in advance. But I'm happy that we didn't have any serious issues so far.
Yeah, congrats on that, of course. And let's jump to the next question.
Yeah.
In your opinion, is passwordless authentication the best practice? What are some other upcoming technologies here?
Yeah, so absolutely, passwordless is something that the industry, they are learning it right now, because now this technology is becoming more and more prepared to be used by everyone. And you can hear about many websites in the news that, for example, I think the last one were GitHub that started they rolled out passkeys for everyone. Now you can create a user with passkeys. Passwordless, now it's called passkeys in the news. So yeah, passwords will be gone in a few years. I have no doubt about it. It will take time, but no doubt that this will be the next thing. Like everyone says that, but people still need to learn the technology, because I see a lot of difficulties in implementing the passwordless approach in your websites. There are many ways to do it, many difficulties, many gaps that you need to give answers for. So it will take time, but we will be there, I'm sure.
And maybe also a bit of trust from the user.
Yeah, that's also.
While we are at giving this outlook on the future, this question fits perfectly. In what ways do you see passwordless authentication evolving in the future, considering emerging technologies and security requirements?
So in what way do I see passwordless authentication evolving in the future, considering emerging technologies and security requirements? So I believe that all the hackers will need to learn about this technology, because I'm sure that there will be many vulnerabilities around it, and there will be many things that the community will need to answer, because there will be many issues that will rise. That's what happens with every new technology. People understand that this is the new thing, and then let's break it. Let's see what's wrong with it. So I'm sure that it will happen. I really can't tell what will happen regarding the security of this one, because as for now, it's really looks like very promising in terms of security. I can't tell so far about someone that says this is not secure. We are not there yet. Maybe in 10 years, we will have the next passwordless thing. But for now, it looks like this is like the top security that you may have.
All right, thanks for that answer as well. Let's jump to the next question. How do you balance the need for user convenience with ensuring the highest level of security in a passwordless authentication system?
So how do we balance the need of user convenience with ensuring the highest levels of security in a passwordless authentication? So actually, passwordless authentication is something very unique, because it enhances the user convenience. It makes the UX to be the best you can have. And it's also enhanced the security, because in passwordless, it's actually something you are, because it's your phone, it's your biometrics, and it's something you have. So like it's like a multi-factor authentication, but just with your finger. It's very fast. It's much faster than regular authentication, and it's much more secure. So it's like a win-win situation. So yeah.
Sounds like it. Thanks for that answer as well. Next question. What is the first step I need to take in order to become a DevOps engineer?
So I will tell you my story. Actually, one of my managers in the past just threw me into the water, into the deep water, okay? Because I knew some things about AWS and very generally, and then he told me, we need to duplicate an environment from the US to Europe for a new customer. And then I understood that I need to learn a lot about AWS, about Terraform, infrastructure as code. So you actually learn the best from hands-on. I was lucky to actually have the time to invest in a project. And then I took a few Udemy courses and I made the AWS certification. So actually I learned by doing things.
Learning by doing, as it is so often. Thanks for this valuable tip. And we jump to the next question. A rather quick one, I would say. Can you share your LinkedIn profile so we can learn more from you in the future?
Yeah, I will send it, sure.
Perfect. We can share it just in the chat then for all attendees to keep in contact with you. Okay, next question. A more technical one again. Were there any specific challenges faced when integrating these technologies?
So I will assume the specific challenges that we faced were integrating these technologies. So the question is if we can talk about, I guess it will be about the passwordless technologies and not the cloud front and all what I talked about, the AWS aspect. So the difficulties while integrating the passwordless technologies, there are tons of challenges because there is the challenge in the aspect of the developer that's doing it. That's one aspect. And the second aspect is the challenge that the end users may face. Because if the developer won't do it in a perfect way, then the end user may see many rare things during using the passwordless. For example, if an end user logs in with one phone and then tries to log in using his Mac touch, then if you are not handling the edge case of multi-connections, like storing multi-credentials on the backend, then many weird things may happen. And also when you're developing the passkeys, there are many libraries that you can use. Not all of them are FIDO certified. And if you're not implementing it exactly as you need, you may expose your company to many security breaches. So you just should read the tutorials very carefully and use only trusted services and libraries to do it, because it's the authentication. It's like the most critical part of your system.
It's potentially very dangerous.
Yeah.
So very valuable tip also there. We jump to the next question. What was the motivation for the need to improve the authentication process?
So the motivation of most of the companies that want to improve the authentication process is actually they want to increase the conversion rate. If they sell something, they want to sell more. They are seeing many customers. Every company has metrics. They see where people drop off the process. So they just saw that people are filling their basket, like they're collecting all the products that they want to buy, then go to checkout, and then you have the huge registration form that asks you for many details. Where do you live? Which passport do you want to use? What is your email? And then just people close it and go to another website. So that's exactly where you can just add one small button, ask for the biometrics, tell the end users, just touch here, tell me what's your name, tell me what's your email, and let's move on. And later you can collect all this data. So that's what we do with some of our customers, and you actually see that we increase the conversion rate in around like 30% more people are identified to websites, and it's actually a dramatic ROI for them. So that's the motivation to improving this process. Yeah.
Yep, can understand that. Thanks for also sharing that. And next question. Does your approach also work with another observability service than Datadog?
So we worked also with LogRocket because we wanted in the past to understand how our end users behave. Okay, we wanted to understand where they drop off our product. What is our issues? We wanted to increase the conversion rate inside our internal flows. So we use LogRocket to record end user sessions, and we had some amazing insights from this product. And I have some custom-made, as I already said, we have some custom-made dashboards inside AWS console. You can use CloudWatch to create very amazing dashboards inside. And before to that, we also had the ELK stack. We had an in-house Elastic Search, Open Search in AWS. We collected logs in that way in the past. It was nice, but then we understood that Datadog gives us many, many more features.
Makes perfect sense to me. And we got one more audience question. What are the potential future implications of the adoption of passwordless authentication?
Potential future implications of the adoption. Let me think. So actually, it's like democratizing the authentication. The way that we are looking on authentication will change. The registration, login, everything, it will be like unified. You won't even know if you're registering to a website or logging into a website, because you will just see the website, you will click a button that will say identify yourself. Then you will touch Face ID, Touch ID, and then you are in. You won't even know if you just registered, you logged in. Like, it will be very, very easy to companies to know who you are. Yeah. Not sure that it's good, because then many companies can use it for bad things. But I guess that this is where the world is heading. Okay.
Yeah, all the personal data stuff, it's it's a bit scary to look into the future of that. But yeah, and also maybe also as a closing question to you, do you have maybe some additional resources you can share with the audience about all the passwordless stuff you talked about? Maybe some blogs, even books, YouTube channels, videos, maybe?
Yeah, sure. So actually, you can take a look at there's a website, passkeys.com. It actually collects all the best approach in how to implement a passwordless authentication by yourself without using any third-party service. Actually, a very, very straightforward brief to implement on the front end and on the back end in the most simplest way. That's a very, very nice starting point if you want to learn about FIDO, WebAuthn, and all these technologies. This is really the best offer I can give you.
All right, thank you for also sharing that, and thanks for the awesome talk you gave us today, for all the information you shared during the talk, also during the Q&A. It was really a pleasure having you, and hopefully see you soon in another live day.
Thank you. Thank you very much.
Thank you. Bye.
Bye-bye.
All right, and before we jump to the last talk of the day, just a 20-second break. And let's get ready for the final speaker of the day. She is senior software developer at JReleaser, And not only a Java champion, CDF ambassador, hacker garden enthusiast, and open source advocate, she's also a public speaker and mentor. Welcome, Ishel.
Thank you very much, Benny, for having me here. I'm super happy.
We are happy to have you, Ishel. Thanks so much for joining. So, before we start your talk, would you mind sharing with us a bit about what we're going to learn from you?
Okay, so this session is about GitHub Actions, and I'm going to cover a lot of the theory, some of the things that I have found really interesting, and some of the gotchas that I also encounter when using GitHub Actions. The other part, the demo part, I'm going to show a little bit of the process to use reusable workflows and how to refactor, for example, when we are targeting Maven Java, because that is also my background.
All right, Michelle, then I would say without further ado, the stage is all yours.
Oh, thank you very much. So, well, welcome to Light Camera GitHub Actions. I'm really happy to be here, and this is how you can find me on Mastodon Social and LinkedIn. And as Ben introduced me today, I'm a Java champion. I also collaborated in 2 books. The latest one was DevOps Tools for Java Developers. I'm from Mexico, but live in Switzerland. But today it's good morning from Cuernavaca in a very lovely, almost 32 degrees. So I'm fantastic and happy to be in October with this weather. So let's start with why GitHub Actions. I'm going to do a very brief recap of the most basic concepts. So don't worry, bear with me. We will get into the slightly advanced or not so advanced because there's always something new to learn. So why GitHub Actions? Why today this particular topics? Well, it turns out that there are 95 million developers on GitHub. This is according to the October's report from last year. They checked the statistics about what projects, what programming languages, how many repositories, for example, their build times, etc., etc. So 263 million jobs runs, and with more than 41 million builds minutes a day. The 3 main programming languages is JavaScript, Python, and Java. So that's the reason why we are going to talk about Java and Maven with GitHub Actions. So probably you all have a slight idea of what are GitHub Actions. And here, I mean, this is DevOps Day, so I don't have to go and stay so much into this one. It's about build, test, and deployment, your pipeline. This is something that comes like, of course it is. But it's not only that. So you can run workflows when other events happen in a repository. So it's automate as a very extensive list of actions and activities, workflows that can do many things, from creating labels, starting an outside process in a different server. So honestly, the sky is the limit. And this is how I like to summarize what a GitHub action is. So events trigger workflow that contain jobs that define steps that execute actions. And the jobs are running in different runners. And they can run usually in parallel. And the other important thing is that there are 2 types of runners that you can use, the GitHub hosted or your self-hosted. I will touch a little bit of the details about the difference of them. They support the 3 operating systems, Linux, Windows, and macOS, and 3 architectures, ARM64, ARM32, and x64. ARM32, it's only for Linux. And so this is, in summary, what it is. It contains 1 or more jobs which can run sequentially or in parallel in each machine runner that has 1 or more steps that either run scripts that you're defining or actions that you can create or you can consume. So what are the events that can trigger a workflow? There are 4 ways mainly to trigger a workflow. There are going to be responding to events in your workflow repository outside your GitHub repository with repository dispatch event on GitHub, scheduled or manually. And some events also require the workflow file to be present on the default branch of the repository in order to run. This is important. If you are in a different branch and creating a specific workflow, if you're expecting it to run, sometimes you will have a very interesting surprise. It doesn't. And the only reason is because in main or your main branch is not that particular workflow is not yet defined, it's not yet merged into your main branch. So take this in mind, learn from a lot of people that have found this surprising, and make sure that at least have a version of the workflow defined or merged already into master. These are all the events that you can listen and you can react inside the GitHub repository. And probably you already know most of them. So for example, create, pull request, push, release, and the workflow dispatch. This is to manually run, for example, your workflows. And in this case, for example, create will respond or react when a branch or attack is created. For example, push is when something is pushed into your repository branch, but it's a commit, a tag, a branch is deleted, a tag is deleted, or a repository is created for a template. So, and for example, there are some limitations. If you are using the create, but you create, for example, more than 3 tags, that is not going to be triggered. So that's a limitation on create. And make sure that you remember this. The other way to schedule or to trigger workflows is through a schedule. They follow the POSIX syntax. So hours, minutes, days. This particular one, the first example on the left, is going to be run every day at 5:30 and a.m. and p.m. UTC. And in the other side, you see we're introducing already some interesting syntax. It's set conditional. And we're saying that the GitHub event schedule matches in a specific pattern, it has to be skipped. So in the second workflow that I have on my right, this is only going to be run, from the first day, Monday, Tuesday, Wednesday, and Thursday, but the first step is going to be skipped on Monday and Tuesday. So conditionals are really important, and we will see more about the syntax and the potential in a few slides. So how are you going to trigger also the workflows? Well, you can use events and event types. For example, you can have a single event reaction or multiple ones. The other one is using event types. For example, here I'm saying that I want to react when a label is created, or there is a push on a branch main, or there was a change on the page build. But there are some times when things are going to be a little bit surprising. For example, in the last one on issues type, open, and label, what happens if you create an issue with 2 labels is open? Like if you create that, well, the workflow is going to be triggered 3 times. 1 for the issue open event and 2 for the 2 issues label events. So make sure that you're choosing your triggers carefully, because otherwise you can end up with a very redundant way of running or triggering the workflows. And for example, using filters. So this is one way to start creating this. So one is you can use branches, and you can say, well, on pull request, if there was anything happen on the branches main or Mona AutoCAD or releases, do something. Or the negative case, ignore if something happened on these two branches. And what happened if we wanted them to combine? We cannot use branches ignore, and branches at the same time. We have to use a different syntax with the negation. And we all know that one from so many programming languages and configurations. And it is important the order where you define the logic. If you define first the positive or the negative. So one is going to open and the other one is going to reduce the scope. So for example, here, if there is a push into a branch that, for example, is the releases /10-alpha, this is not going to be run because it's being ignored by the second line of this specific filter on the workflow triggers. Tags work the same. So we have add the tag or tags ignore, and it's going to follow the same principles as with the negative syntax. And guess what? Paths too. So for example, you can also say all the files that are under this particular path with this particular file type or pattern, and you can also ignore it, and you can also combine it with the negative syntax. Now let's talk about communication between the different workflows, because sometimes they need to communicate between themselves. So the communication between information between the different workflows or between the jobs or between the steps, it is going to be through context variables, environment variables, outputs, and inputs. And for example, when you use jobs and the job ID and outputs, you are creating a map of outputs for a job. And the job outputs are available to all downstream jobs that depend on these jobs. There are some things that you have to consider. Outputs are Unicode strings, yay, but they can be only a maximum of 1 megabit. And all the outputs in a workflow can, like in total, you cannot be beyond 50 megabytes. So think carefully. And contexts are a way to access information about workflow runs, variables, runner environments, jobs, and steps. Each context is an object that contains properties, which can be strings or other objects. And we usually use that syntax to reference to the context. Probably you saw it before. And you can access context using the expression syntax. Variables are the other way to also send information. And this will have a lot of importance when we talked about reusable workflows. So variables provides a way to store and reuse non-sensitive configuration information. And this is important, non-sensitive, because the sensitive, for crying out loud, we use secrets. And when you're using a secret, please store it in a very simple object, because if you use a very complex object to store a secret, then GitHub is not going to do that perfect job when masking or extracting or filtering some of the things that you will see in the next slides. So that could be a problem. So only non-sensitive data and even secrets, please be mindful that you should have the simplest, non-very hierarchical or composed objects to define secrets. And variables, and this is important, are interpolated on the runner machine that runs your workflow. So it depends if you're using PowerShell, if it depends if you're using a shell, or how you're going to reference it. But don't worry, I mean, you are going to define what is the operating system of the runner that you want to have, and this is going to be very transparent. And the commands that you run in actions or workflows in the steps can create, read, and modify different variables. So how do variables work? How can you define it? Well, you can define it in 3 different scopes into the workflow. At the entire workflow, you use the emp at the top, a job within the workflow, or a specific step within the job. And this is something that really is important. Environment variables exist only on the running that executing the job. So let's see, this is the example of the 3 levels that I explained before. At the workflow level, I have day of the week. At the job level, I have greetings, hello. And at the step level, I have first name, Mona. So as you can see, we can use it on the run part, and we are creating this greeting first name today is day of the week. But there is also something interesting there. I have a conditional, and I'm referring to day of the week slightly different. And why is that? Because this particular conditional is going to actually explain or redirect how this specific workflow is going to be run. This is not passed to the runner. So we need to use in the conditional statement a context. That's why it looks like day of the week equals Monday. Now, I explained that you can have environment variables in a single workflow, and that was the example at the entire workflow, at the job, at the step. But there is another way of communicating environment variables between multiple workflows. And multiple workflows, for example, configuration variables, can be accessed through the vars context. And this is an example exactly of that. So here in the line 5, we're saying the environment vars, we're saying vars, environment context vars. So now this can be shared into the different workflows, and it's very, very useful. In the demos and the GitHub repository that I have that comes with the demos part, you can see the examples of this. So don't worry, I will put the QR at the end and everything, all the information that you require. Now, this is very interesting because this is a way how you can print the entire context, and the context of the GitHub, of the jobs, of the steps, the runners, the strategy, and the matrix. So all the information that comes or it's being gathered when in a specific commit it's being evaluated inside the workflow, you can access like this. So this is something for what I tell you that you should be very careful about adding only context and as an input, or adding only information that is not sensitive inside context, variables, or whatever you define. Because, for example, GitHub is going to mask secrets, but not if they are not secrets. So if you're passing sensitive information and in some way you forgot to remove it, or any logs or any printouts to the output of the jobs, it's going to be very problematic for you in terms of disclosing things that you may not want to have disclosed. I already talked about outputs. So we can create outputs and define outputs and require outputs to pass information between the different workflows. For that, we can create a map of outputs. And once you have a job that is defining outputs, all the jobs that are inside this on these jobs is going to be available for all the downstream jobs that depend on this one. And the outputs are Unicode strings. Excellent. The maximum is 1 megabyte. And again, the total outputs has to be 50 megabytes. And this is an example of what is like how do you actually define the outputs. So in the first job, we are saying you will have 2 outputs, one of a step 1, one of a step 2. That's why we are defining in line 5, 6, and 7. Then we only add hello world in different ways, like in line 10 and in line 12, and we send it to the GitHub output. In the job 2, we are specifying with the depend, and we will see more about dependencies, from job 1. And we are actually reading in that environment variable the output of the job 1 step 1 and the job 1 step 2. And then we are printing hello world. Okay, now remember when I said that we could trigger a workflow via manually? Well, because this is typical, and there is something that probably you need to start using if you're not using it like already. For example, in the code, well, in the configuration file, in the YAML that I'm showing, you will see that we have different inputs. And I have something interesting. I have type choice, type Boolean, type string, and type environment. And in the choice, I even adding the options. I'm saying info warning on debug. So now when you are trying to run this specific workflow, you require inputs, you don't have to enter everything. If you have already predefined the possible universe of solutions, why don't you use a choice? Or if it's a yes or a no, use Boolean. So the inputs that you're receiving, you can access them in GitHub Events input context. That's what we are doing underneath. And the maximum number of top-level properties for inputs is 10, so you cannot go that crazy. And the maximum payload is 535 characters. And this is what I was saying. This is how it actually looks. In the demo, it's there, and we will see it. So you have drop-down menus, you have choices, which are Booleans, and you will have also environments and strings, normal strings. Now let's talk about jobs. And I'm going to go a little bit faster so we have time to actually go through the demos and the examples. So workflow run is made of one or more jobs which run in parallel by default. Sometimes we want to run them sequentially, and we will see how that happens. And we will have to use the need keyword, and each job runs in a runner environment and specified by runs on. This is where you specify what operation system do you want. And you can run an unlimited number of jobs as long as they are part of your package. And you will say like, so what are my limits? There are 4 types of limit: the job execution time, the workflow runtime, the API request, and how many concurrent jobs can you have. You can only run a job for up to 6 hours, and then it's going to be terminated and it's going to be deemed failed. The workflow, the entire workflow, the limit is 35 days, and this period includes execution duration and time spent waiting, for example, for an approval. The API request, you can execute up to 1,000 requests in an hour across all actions within a repository. Then if the requests are exceeded, then the jobs will fail. And the concurrent jobs, this depends on what plan do you have. But for example, you have 5 maximum in Mac OS X runners, and you will have a different number. For example, I only added the free part, which is 20 concurrent jobs. Now we started with jobs, and this is something really interesting. So in the left side, sorry for that, we have that job 1 must complete successfully before job 2 begins. And job 3 needs to wait both for job 1 and job 2 to complete. Now, what happens if job 2 fails in this example? If job 2 fails, then job 3 is skipped. And then maybe that's something that we really want. But what happens if we want a more complex way or workflow or story? That's when we use always, failure, or other types of expressions and inside a conditional. For example, in the other example on the right side, job 3 uses the always conditional expression. So it always runs after job 1 and job 2 have completed, regardless if they are successful or unsuccessfully. So we need the need and if always. Conditionals. We have talked so much about conditionals. What can we condition? Well, in the first example is when the production deploy job can run. It will only run if the repository is named octo-report-prod and is within the Oct organization. Otherwise, it's going to be marked as skipped. And the second one, see, and this is when things started to get more interesting. That particular step, because it's applied at the step level, will only run when the event type is a pull request and the event action is unassigned. There are several functions that you can apply. For example, example 3, it says, and doesn't start the GitHub reference with reference tags. Or you can have pretty much comparison as we try to use it with patterns, like completely literals there. Now, remember when we were talking about the branches, the tags, and filters, and everything like that? Sometimes we want to reduce the number of a specific runs or workflows that are triggered in a specific group. So we only want a single job or workflow using the same concurrency group that will run at the time. For example, if we are updating so fast, we don't care about the old trigger of the workflow. We want to cancel them and always dedicate all our resources into the newest versions of our particular, for example, workflow. So this is when we start using the group's names. And the group names have to be unique across the workflows, because if they are not unique, you can start killing or suspending or canceling different jobs across different workflows just because they share the same group name. You can have fallback values because, again, the different event types, a workflow can be triggered by different types of event types. So, for example, if one is being triggered, but that particular event doesn't provide to the workflow that a specific information that is required to calculate, for example, the group name, you can have fallback names. So that's why you have the OR. But as you can see, you can go nuts and creating unique norms for the concurrency groups. And now, finally, reusable workflows. So every single time that a specific workflow calls another workflow, one is called the caller, and the other one is going to be the one called the called. So one caller workflow can use multiple called workflows. You can only connect up to 4 levels of workflows and maximum of 20 reusable workflows in a single workflow. And this is the part where how do we communicate with different workflows? What are the contexts? What are the variables? It's going to be very important. So any environment variable set in an environment context defined at the workflow level in the caller workflow are not propagated to the called workflow. Similarly, environment variables set in the environment context defined in the called workflow are not accessible. And to reuse the variables in multiple workflows, we can set them at the organization, repository, or environment level and reference them using the var context. We saw an example very early in the slides. And reusable workflows are called directly within a job and not within a job step. So keep that in mind. And this is an example, and sorry, I try my best to put the font as big as possible, keeping the two files, the two different workflows at the same page. So this is nothing really sophisticated because we have seen all the elements already. And what I'm doing here in the reusable workflow, I'm saying we are going to define two particular outputs, hello world, well, hello and world, and in the caller is going to use or require this particular reusable workflow, and it's going to need the outputs of job 1. And finally, it's going only to concatenate the outputs and print hello world. So this is how you start using your reusable workflows and start passing information, either as an output, either as an input, or either as bars inside the context. There is something important that you should take into consideration: secrets. There are two ways of passing secrets, and the GitHub token is usually passed, so you don't have to worry about that much anymore. But for example, all other secrets that you have between different reusable workflows have to be defined. Either you inherit and pass all the secrets, or you can define with granularity what secrets do you want to pass. And for example, in the workflow chain, A passes to B to C, workflow A has a package with token permission. So B and C can never have a write permission. So keep that in mind. Every single time that you jump into the hoop, you are going to reduce the permissions on your secrets. And a GitHub token permission can only be the same or more restrictive in the nested workflow. So finally, we're going to the demo. So as I said, the slides are going to be available. You can see the QR code there. Let me stop sharing this screen and let me start sharing my window. Well, this is the window. Okay. So the marketplace. The marketplace will show you how many actions do we have or GitHub has in their marketplace. Right now it's above, like it's 20,290. One of the important or interesting things about the actions is when you start with your repository and you don't have any action defined, but you already have some code, GitHub Actions actually is going to use information about what is the programming languages of your project and starts and will give you some suggestions about what are the startup actions that you can start using. So in this case, this is my repository. We have different of the workflows that we talked about and some others that is going to be the reusable and refactor workflow based on Maven and Java. So the first one that I wanted to show, because we talked about it, was the basic inputs. And the basic inputs, as you had it in the slides, it is the different types: choice, Boolean, string, and environment. And if we see how it tries to run it, you can see here, well, this is nothing sophisticated because you can always select what branch is. But for example, in the log level, these are the choices that we said: info, warning, and debug, which are these ones. And for example, this is the choice. No, this is the Boolean. So you can only say yes or no. And finally, the type of environment. So now you are preventing people from entering not the right input for your workflow. And I find that very, very useful. Now, the other one that I wanted to show you, remember the job examples that when do we have need and when do we have always. This is the one that I wanted to show you. So job 1, it's going to run on Ubuntu. It's going to have a step 1 that is only saying this. It says echo hello world job 01, It's passing Markdown, as you can see. Where? It's passing it to a GitHub step summary. Okay, that's new. We didn't talk about that one. And then we add a second job. And this depends on job 1. And it's going to say that job 02 depends on job 1. Okay, but step 1, this step, is going to fail. And we actually make it fail. And the second step, we're going to say, if there was a failure and the conclusion of the step 1 of the job 2, this one, it's failure, we have to run it. So, and we will say the only thing that is going to be an echo into saying that step 1 has failed. Job 3 depends on job 1 and job 2. That's okay. And this, because this is going to depend normally, like you don't see here any always or failure, nothing. This one is going to be skipped because we are making sure that the job 2 is failing. And job 4, it's always going to run. Depends on job 1 and job 2, doesn't depend on job 3 because job 3 will never execute, in these conditions at least. And we are only saying that job 4 depends on job 1 and job 2, and it's going to the GitHub step summary. And this is when we actually are going to see the output. So when we start running our jobs, we get this fantastic graphic. And as you can see, I have job 1, job 2 fails, job 3 is skipped, and job 4 is executed. Remember that GitHub summary with Markdown and emojis? Well, this is a job summary. And as you can see, I prefer a little bit this because it looks easier. And I'm controlling what is the output instead of going to the log files and seeing all the lines of what was executed. So this tells a really nicer story. So job 1, it was okay. Job 2 depends on job 1, but it will fail because we make it fail. And this was triggered because step 1 has failed. And job 4 is going to be run regardless of the state. Okay, so let's go back to the examples. And this is going to be our workflow based on Java. What we are going to do, we give it a name because it's easy to find them. It's going to be a workflow dispatch, which means that we need to run it manually. It has this specific job called build. It's going to run on Ubuntu. It has 3 steps, which is checkout, set up Java, and then build. We're going to use cache. I didn't mention anything about cache, but if you go into the documentation, you're going to see how it's going to allocate it, how much time is going to last, how it triggers, how calculated miss, and how it actually finds it, what do it actually uses to find different cache. So it's really interesting, but in this case, we know when we are building something with Maven, sometimes we download the entire internet. So it is important that we cache our this particular setup of the Java action. And well, NPM doesn't do a better job with cache and downloading tons of stuff. So NPM also, I totally suggest that if you're building, use the cache for NPM. And finally, what we're doing is using the Maven wrapper and we pass specifically the POM XML and we run the verify. Because see, we can even go to a specific folder. And so that's why we are specifying what is the POM XML that it has to be. This is also a very trivial Maven project, but it's a multi-project build. Okay. So when I run this actually is going to work. And this is perfect. This is what we want. But what happens if we want to run it? Like, for example, I want to not only do this while we are building, but also when we are releasing. But when we are releasing, there's something important. Building, we want it to build, to run the test all the time. But creating a release, we only want it to happen when there is a push or that doesn't have, like, the outputs of the version is not a snapshot. So what we're doing here, so we have build 2, we have a job called pre-check, and we have one that is release. Here is we're going to have a specific output called version, and we have the bars output version, and we do exactly the same thing. The actions checkout, setup Java, again, version 11, distribution Zulu with Maven. And then we're going to extract. Well, we're going to try to see what is the version that we are passing. So we're using the Maven wrapper, help evaluate, and check what is the project version. And now we check if that project version has a snapshot, then we want to do something or we don't want to do something. So this is a start to be more interesting, more intelligent to actually do a specific release. And that is fine. That is perfect. But what happens if what we are building is going to be built for different operating systems or even different architectures? So this is when metrics are starting to get more interesting. And let's see what is happening here. Again, this we have seen the pre-check, now we have build. And for example, this hasn't changed. We again do a checkout, we cache, we do a set of Java, we extract the version. In the build, we checked that it's not a snapshot. Or if it's a snapshot, we are going to create a matrix of OS. What OS are we going to do? Ubuntu latest, macOS latest, and Windows latest. So we are going to build them on those, and that's it. We only do the Maven verified. Perfect. So this is a little bit more sophisticated. What else can we do? Well, in the next iteration of this is not changing a lot. We are checking out, caching, extracting the version, do the pre-check, like where pre-check means extracting the version. And if it is snapshot, we'll continue. And in this case, we're going to set up GRAL. This is how we set up GRAL with which version, with target of Java version. We are targeting the native image. We are passing the secret GitHub tokens, Maven. And we again set up the JDK, we build, and we assemble. And this is the important part. We are going to use JReleaser action. If you want to know more about that, we can talk about it later on. And we are going to upload the artifacts. We do something similar for macOS. Actually, it is almost the same thing. And that's the whole point here. It is almost the same thing. The only thing that is so minimal, the actual different, that this is what I wanted to show you. Maybe we can extract what is different, because assembling Windows is going to be almost exactly the same. So honestly, dry. Keep it simple. Do not repeat yourself. So as you see, 244 lines of things that almost do the same thing is not acceptable. So we need to refactor. And this is when we're going to do the reusable workflows. And in this case, again, this part, the pre-check hasn't changed. We're still doing the same thing, checking the version. And now we're going to see that we can say assemble, which was super similar for different operating systems. We can actually tell it, use an X reusable native assemble YAML. And if you can see, it's going to be located in the same folder in GitHub Workflows. And we're going to pass it the version, this version that we calculated in pre-check. And then the release is going to use pre-check and assemble, and it's going to use whatever actually assemble created to upload or download the artifacts into the different repositories. So now let's see. And then from 245 lines, we end up with 74. Why? Because we are using the X reusable native assemble YAML. So now we are specifying the inputs that we are expecting with, remember, pre-check is calculating the project version. We need some Graal version and Graal Java versions. And here's where we still have our matrix with the different operating systems. And for example, here's that we set up Graal, we set up all the information, and here is the important part. Here are the differences. So for example, this step is only going to be run if the runner or operating system is macOS. So as you can see with the power of conditionals, with the power of environment variables, of the context variables, of the outputs, inputs, etc., we can reduce, refactor, and keep our workflows really easy. And now we can start creating the different artifacts, and we can even define with what retention we want. In the free version, you can retain the different artifacts between 1 day and 90 days. In the other ones, it's more days, but you can control it here. In this case, we don't want to maintain them for long, so only for the end of the day, because for our purposes here in the workflow. Okay, let me see. Let's go back to the workflows and let's see what are also we are missing. So this is the one, this hello world is the basic hello world that is going to be provided by GitHub Actions. They change it from time to time, but this is interesting because, for example, it shows you some of the basic syntax that I didn't show because I assumed that we knew a little bit about GitHub Actions, where, for example, how to run a multi-line scripts. And even in the basic one, they are already reusing workflows. So it's interesting that even in their reusable, in their hello world version, you're already defining inputs with the different types of inputs and even with default values. Because, for example, if it doesn't receive any value for the caller, then the called is going to use the default into the name John Doe. So I can say the username is whoever. If I pass it, and if I don't pass anybody, it's going to pass John Doe. Okay. What else? The environment. This is also something interesting. The environment can accept different kind of expressions, as you can see, can find null, the actual value null, booleans, integer, float, hexadecimal, exponential. And you can also even start formatting in different ways and concatenate. So for example, in the GitHub step summary, that one we saw with the jobs is going to print beautifully this particular environment variables. This is a very interesting jobs with needs and dependencies and running that we already saw. And this is the variables that how to pass variables and configuration variables between different contexts. Like this is not only defining variables at the workflow level, at the job, or at the step level. This is going to be shared, and you can actually define them inside the settings as a variables of your workflow. Let me stop sharing this one and go back to sharing something else. So as I promised, the demo are going to be in that GitHub repository. There is a QR code, and I lost my mouse. I found my mouse. And that's it. I hope I show you something new, at least something that you didn't know. I know that I skip very important information, for example, how we are encrypting the secrets or more advanced information on other specific topics of GitHub Actions. But these are kind of the most important ones for me. This will get you up and running, and at least when things are really strange, like, for example, why my workflow is not running because I'm defining it in a different branch that it's not main, and suddenly this doesn't work. For example, that it has to be defined, at least for some events, it has to be defined in the main branch, or some of the gotchas, like how many, what are the limits in terms of number of variables, in terms of the size of the variables, etc., etc. And I'm always looking for feedback about my presentations, what I should explain more, what other topics should I talk more about, the different concepts that are showing. Please let me know. That helps me a lot. And you can connect with me in Twitter, in Mastodon, or in LinkedIn. I'm more than happy to chat. And that's it. Thank you very much.
Ishel, hello again. Thanks so much for the talk.
My pleasure. Later.
And yeah, since we have some time left, I would say let's use this few minutes for a short Q&A, if you're ready. Perfect.
Yes.
Ishel, I read in your bio some, I would say very impressive titles and roles. And so I'm interested in your developer story. How did you become interested in tech in the first place? And what was like, your journey from there on?
Okay, I'm going to super date myself here because I'm going to tell you when I was still in high school. And for example, I fell in love with Linux. And this is the time where back in Mexico, with the distributions, you literally had to go to your Linux enthusiast of trust, and he or she will burn you a CD and you will go into your machine. And it was the most scary thing because at that time you have to partition your master boot record, you have to do almost everything by hand, you have to compile your drivers. So it was scary but exhilarating. So I fell in love with computers. I fell in love with Linux and the command line and things like that. And that when it came to choosing my career, I said, it has to do with computers. It has to. And from there, I became a Java developer. That's why I'm passionate about the technology. I'm passionate about the community. That made me a Java champion. Again, I'm very proponent of open source, so I try to help open source projects into adopting different and making sure that we are doing open source in a better way by helping developers, contributors, maintaining, helping people to adopt and contribute back. So that's why I'm part of the CDF, the OSSF Foundation. I'm part of different initiatives to create standards or to help open source projects.
All right. Yeah. Thanks so much for sharing this with us. And let's tackle some of the questions from the audience, I would say. First, what's the biggest benefit of GitHub Actions compared to AWS Code Pipeline or Azure pipelines for you? Are there any features missing that the competitors have?
Well, first of all, again, there are no silver bullets, and that's great because there are no werewolves out there. Second of all, GitHub Actions, even though it's very used, and that's one of the reasons why I tried to explain at the beginning, it's one of the platforms for version control system that is mostly used here. Like it's the most popular one. So that's one of the reasons why to start with it. They are free, and we discuss a little bit about the limitings that you have, like for example, how many runs that you can create in the free tier or in the free version. So I have to say that there are some things that are still young. For example, rerunning failed jobs was a topic 2 years ago. Well, year and a half. We had so much problems with that. And you would say, well, rerunning failed jobs is kind of like basic. Why did it take them so long to create it? And why did we have, like, for example, 1 month between, oh, this is a way to do it, or no, forget about it. We totally messed up with that solution. We have to roll back. So, what are the advantages of GitHub Actions? It's only how widespread is their platform. And you can start really easily because chances are that you will find a project in GitHub that you can fork immediately and you can start using them. If you're talking about production code, something that you have in your private repositories, then the answer is going to be more towards integration between tools. If your technology stack is already on AWS, probably that's going to be more a decisive factor. Here, as a consultant, and this I'm going to use my cap as a consultant, is we need to understand what are the maximum capabilities. Where are you pushing the envelope to decide what is you're going to be your provider? We have to define what are the limits of not only how fast, but only the functionality that you want to provide, and then decide if the current technology stack met that particular one. If you ask me about the functionality, they have all elements that you are like, honestly, Jenkins solved this like 5 or 6 years ago. How come you cannot solve this particular issue? And I can say that to GitHub, and I can say that to Amazon with code, or to Azure. So again, the answer as a consultant, it all depends on what do you need, what do you have, the integration, and what are your goals. Do they are perfect? None of them are perfect. But maybe they fit your specific needs. And I'm not only talking about performance and functionality, but they may be also business decisions there.
Yeah, I think you won't be surprised if I tell you that it depends is an answer I get very often during these Q&A sessions. All right, but nevertheless, thank you so much for this. And we go on to the next question. How does GitHub Actions event-driven architecture triggered by events like pushes and pull requests enhance software development workflows?
Well, I mean, the question is even giving us part of the solution. So again, continuous integration, continuous deployment means that we are trying to introduce new functionalities or even update or increase the quality of our work, refactoring. So we usually as developers are working between these two, sometimes against goals, like new features very fast or improve the quality of the existing code, like tackling technical debt. So if you are creating a lot of these workflows to check your security, to check your quality, run the different tests, and for example, when people ask me, how many tests, when do you should start running? And I answer is always run your test. There are some tests that are more expensive than others. So that's why you may have different paths for creating different structures of how your pipelines are going to behave. So by combining how you react to improving your code or adding new features very fast and with more options into how to react, like for example, integration test, contract test, or even very extensive tests in terms of time or in terms of runners, you may want to only run them during the night, once per week, once per month, or whatever you define. So both of them will give you more options into how to define these stories, these workflows, and to improve your ultimate goal.
Thanks for that answer as well. And we got another question. Are there any companies or open source projects that have effectively implemented GitHub Actions for their CI/CD pipelines?
Yes, there are very, very much. You can actually in the Octoverse, and I put the link into the report, they will have show you what are the most popular GitHub projects that are using GitHub Actions to build, for example, for different kind of architectures, um, their projects. So if you go there, for example, VS Code does some of the command line interfaces, some of the projects, but you can see the actual list there. They do have it. For example, how many runs and how many build times, build minutes do they spend? So that's a very interesting questions, and I totally recommend you to go to the Octover's report.
All right, thanks for the tip. And we have enough time to tackle the next question. So there it is. Do you have some tips for optimizing GitHub Actions workflows for performance?
Excellent question. So as you saw, we have this graph where you can see the dependencies between your projects. You can also create, run them in sequential in parallel with needs. You can also start creating your groups for concurrency. The other thing is you can add caching to reduce how much time you're spending into that one. Use already predefined but certified action, and this is important because for example, some of them, for the checkout, some people are always telling me like, oh, but I can do a checkout by myself. But for example, things as small as a shallow checkout, like you don't need, for building a project, you don't need the whole freaking GitHub story. So a shallow checkout will be super performance, super light in terms of how much information you are going to bring, which is an entire source code, but not the entire story of what has happened. But again, you have to be very careful about what actions you're introducing and what permissions you're giving. And again, how are you communicating information between the different workflows? So see your dependency graph, check that there are supported and verified actions of activities that you're already doing, and use cache. I cannot stress that one much.
All right. Yeah, thanks for clarifying also that. And we got one more attendee question from the audience. How do you see GitHub Actions evolving in the next month or years?
Okay. They are changing. So good news and bad news. Good news first. Good news is they are always bringing new features. Bad news, sometimes they tend to break compatibility. Sometimes you need to double check that their actions are, for example, in the latest syntax. You have to update them. There are some things that will be a little bit different if you let them still for far too long. So how are they going to evolve? Really fast. They are going to bring more features. I had for the previous version of this session, for example, a hello world. When I was refreshing and retesting all my examples, I went and generate the new hello world that they suggest as a workflow. Turns out that everything was different. And we're talking about hello world. I'm not talking about rocket science here. So my suggestion to you is keep track of all the new features. I think they're going to be supporting even more operating systems because the versions of Ubuntu for macOS and, for example, for Windows. So things like that. They're going to improve performance. They're going to make more of the functionality about, like, for example, working better with jobs faster. And they are investing a lot because, as I said, there is no bulletproof. They are on the young side, still GitHub Actions. So they have to mature even more right now. They are production ready. Don't get me wrong. They are production ready, but there are still some repetitions that we have to avoid.
It's all a process, isn't it? All right, Michelle, and maybe as a closing question, you already gave us some examples, but maybe do you have some additional resources do you want to share about this topic? Maybe some blogs or YouTube videos or even books, maybe? Something like that?
Yes, totally. I can recommend you the documentation. That is interesting. Even though they are changing so fast, they try to keep the documentation up to date. There are other, for example, certificates that you can start. I haven't done it, but a friend of mine, Benjamin Mushko, has created a certificate for GitHub Actions. So this is something that it's interesting. More and more for this kind of very ubiquitous tools, you can have like official tools to be better. But the documentation in itself for GitHub Actions, it's really good.
All right, then to the audience, check it out to get further information. And Michelle, thank you so much for joining us today. Thank you so much for your talk and also the Q&A. It was a pleasure having you, and hopefully see you again on another live day.
Thank you.
Thank you. Bye. All right. And now, after the final talk, also this live day comes to an end. Now is the time for you to maybe check out worldcongress.dev if you're interested in our upcoming World Congress, which takes place in July next year, also in Berlin. And we will also provide you with a discount code for the live day community for further 10% in addition to the prices of the early bird ticket. So make sure to use that. And hopefully we all see each other in 2 weeks on October 18th when it's all about health tech. See ya.